So we'll be presenting from one of the systems, and we'll be presenting and speaking from the different systems essentially. Is that fine?
Yeah, sure.
So yeah, where the presentation is visible and we are clearly audible, right?
You're audible. You can go ahead, please.
Okay. So we start in 3, 2, 1. Good morning, everyone. This is Team 53 solution for easy automation of complex decision making. Our solution is called Farming Assistance Portal. The problem statement says that we are in the data era, utilizing which we can give solutions to many real-life problems. However, the process of converting unstructured and structured data into knowledge that can be used for decision-making process is complex. But we were given a model which can do this for us by utilizing AI and automation, wherein a complex decision is based on a large number of parameters. We were asked to apply this solution to a real-life problem to obtain fruitful outcomes. Concisely speaking, our solution is a portal where the parameters, which were mentioned earlier, will be the various factors which affect the growth and sale of a crop. Our portal will help the farmer choose a crop optimized from the feasibility, economic, and sustainable perspectives. Why is this a good business idea? Because it's a novel idea and we'll get a competitive advantage for being the first. Next, the government is encouraging Make in India for the problem solving of the Indian households by Indians. Hence, we can look at it as a private-public profitability business perspective. And around 70% of India's rural households are directly associated with agriculture, giving us a huge customer base, and around 26% of them can be considered well off. So, coming to the fourth point, we can give them a free trial, and when they get the profits, we can take a part of it for our commission for further recommendations.
Let us move on to the challenges a farmer faces while choosing a crop. For profitable sale of produce, farmers must take demand and pricing into consideration. Rainfall patterns and temperatures are highly important for the choice of crop. Labor-extensive crop might increase the hamperment of budget planning of the farmers. Difficulty in accessing credit or government policies can happen due to lack of proper awareness and understanding about the same. Farmers might not be aware of the latest advancements in their fields. Advice of relatives and neighbors can be based on biases and not on latest scientific practices. Vulnerability to exploitation is due to middlemen provide these gullible farmers wrong information or charge them with high prices. Farmers do not even have adequate knowledge about the latest trends in agricultural fields, hence limiting their ability to use technology well. These are the reasons why automation is beneficial in Indian perspective.
This is a brief overview of our solution. It consists of two major parts, that is the knowledge base and tech based part. The knowledge based part is divided into the parameters which we'll be taking in as said earlier, and the other part is the relationship between all these parameters. The tech based part consists of the automated decision making model. Now, in the parameters, the inputs which we'll be taking from farmer are mentioned on the right side of the slide. And a part of it comes from the soil health card, which the farmers in India are given to give the soil nutrition profile. And the other are miscellaneous, like the location, the plot size, etc. Here is a list of parameters and how they are classified for the sake of our model. And here we have color coded it to show how we'll be accessing data for the various parameters. This flowchart shows us the relationship between the parameters. Now, here are a few of them which are interdependent and a few are independent. For example, the sunlight factor by itself is not being affected by any other parameter being independent, whereas the irrigation facilities parameter will be directly influenced by the average rainfall of the area, making it a correlated parameter. When we have to narrow down between few options while the model is working, we use conditional probability where a node will cut down other options for us. Like if at a point there are options called rice, wheat, and jowar as the options, the node of the manpower will shortlist jowar owing to less labor intensity. Coming to the tech data source, Internet possesses a collection of humongous data and the information which we require to create our database. And it can be extracted from reliable and authentic sources like newspapers, books, research papers, government advisories, IMD data for climatic information, and much more through text mining. We will also be taking inputs from the farmer as mentioned earlier. Thus, we made the database for our model.
Let us go through how this decision-making model works. This is a probabilistic decision-making model, which involves taking parameters mentioned here, being treated as nodes, and giving output in terms of probability of how favorable a crop could be. Few of the parameters are independent of each other, and few are correlated, as mentioned earlier. There are two filters that we are using here, that is sustainability filter and profitability filter. These filters are an extra contribution from our side. The sustainability filter is to prevent imbalance of soil nutrition over long time due to overexploitation, while the profitability filter is to ensure that the farmers get proper ROI as they are our target users and hence should be satisfied with the product. Lastly, a solution is sufficiently objective and subjective by giving the crop options and parallelly giving an option of relevant government schemes, thus leaving a decent amount of weight of solution on the farmer. Moving on to the advantages of model, improved accuracy. If agriculture goes wrong, nothing can go right. In spite of complexities in the decision-making process, the power of ML makes the process more accurate. Other features are flexibility, improved decision-making, ability to consider multiple factors, and cost-effective nature. The features of this model are probabilistic modeling, causal relationship, dynamic update, multiple inputs, variable interdependence, and the cherry on top is that we are using two unique filters, sustainability and profitability, for enhancing the output.
Last but not the least, this is a wholesome and need of the hour solution. Farmers are the backbone of India, feeding the nation and driving its economic growth. And these are not mere words and statistics on the screen, but a way of helping many earn their bread and butter. Thanks a lot. We are open to the questions now.
Yeah, thanks. I think it was a good presentation. So I have a few questions, right? So one is, it's very good that you actually mentioned the source for all the parameters. And you mentioned a soil card, right? So just wanted to understand, I mean, how much, it's relevant. I mean, what is the adoption for this health card? I mean, is it like all the farmers now have that soil card, and they really have all these, parameters of the soil available with them?
Yes, sir. This was a scheme which was given out by the government of India in 2019, and in that time itself, it covered up to around 60% of the farmers statistically. So in 2019, it was such a statistic. So now, owing to today's situation, considering the policy has been resumed after the COVID situations as well, the percentage might have surely gone up to at least worst case scenario around 70%. So that still makes up for a good percentage of farmers owning a soil health card.
Thanks. So like you said, I mean, this is really the need of the hour, right? And this solution is so important for our country, right? I mean, all the when it's like a farming society we have, right? So what is the reason, currently, or tell me, right? I mean, what is the actual, implementation, right? I mean, I see there are a lot of startups who are actually focusing on this. This is something very, I'm keep hearing this topic. So what is the current, situation or adoption of this solution? Is there any scope for, something like this? I mean, if it can be launched as a, new service or a startup, I do think it, there is a market for this.
Yes, sir. There's absolutely a market for this because before putting down the solution, we looked for any other alternatives available in the market for the same. But there were few, like there were like one or two, to be honest, and they were also not in the working form. They were not in accessible form. They're not completely developed yet, and the usage is a bit complex. So, considering that, we're not saying that all of the farmers are not technically, technologically literate. Most of them are not. So, I think that no one has yet gotten into the field of making it a really an easily handleable form. So, none of the market has still been claimed yet, and and the other thing being the novelty of the sustainability factor, because there have been cases, and especially in the Haryana region, wherein the soils have been used up, and due to the high fertilizer input and all of those, they are facing issues as well. So I think that none of the other products in the market take in the soil health profile specifically to that depth. So this will be advantageous because it will still consider the factor that yes, the soil is a bit low in few essential nutrients due to whatever practices, as we've mentioned in the parameters list. Let me just show you that. Yeah, so here you can see that in the first column, the sixth parameter, soil treatment habits. It's actually an input from the farmer which asks them their practices, like they've been burning the stumps out and all of those things. So it is more customizable, and other products don't have that. So I think this will be a really great introduction into the market.
Okay. Just last thing, last question, right? I mean, since we are on this chart on the inputs, so the inputs which you require from IMD data, right? I mean, this is more like a historical weather data, right? I mean, in terms of the average rainfall and sunlight and all those. You don't need a real time because we are recommending a crop, right, for next season. So I guess it's all based upon the predictions or historical data, right?
Yes, sir. So even if we have the previous knowledge about particular location's climate, we can definitely predict what can be the future climatic conditions.
Yeah.
Moreover, IMD has
Uh,
been working extensively on interpolation of the probability of what the climate would be in a particular location. And this data has been available as a secondary data source for numerous researchers. So it is very easy to access also.
Okay. Yeah, thanks. So no more question from my side, Vishal. Do you have any?
Yeah, I mean, I have a very different take on it. Do you think this is actually a decision or a statistical problem? It's a very open-ended question, I know that, but I just want to ask, given that you have approached it this way.
So, I mean, you mean to ask, is it even a problem where decision making model is required? I mean, am I rephrasing the question properly?
Yeah, so or maybe, see, decision is required for sure, but is this the approach required, or think statistical approach the way it is there today with some machine learning correlations fits better?
Yeah, it is obviously better because considering the various approaches, we know that we're in the era of machine learning and AI, and it is showing that it is reliable and it is accurate enough. So when we have such an option to pursue to do something good in this field, I think this is a good approach and it should definitely be given a shot.
Also, sir, I want to add that this factor of sustainability and the profitability analysis makes a model very much close to the real world scenario, which in the case makes the requirement, because most of the research papers or the research I'll be going on this field are just taking care of only the soil parameters or either economic parameters. But the a real point is the few how do we tackle the problem very much close to the reality. So the model we have been using helps to predict the crop very much into the real world scenario.
Thank you. I don't have any more questions.
Okay, we can proceed with the next team. So the next team is Team 11. Team 11, can you start your screen sharing?
Sure.
Ananya, are you ready with the timekeeping?
Yeah.
Can we start?
Yeah, you can start.
Great. I hope the screen is visible.
Yeah, it's visible. You can start.
Good morning, everyone. We are very glad to present our findings on the allotted topic of site investigation. So just to give a bit of premise about how did we actually get to this particular topic. So a very recent events that have been happening in the city of Joshimath in Uttarakhand that has been seeing a lot of fatal cracks on more than 800 houses across the city. We came across this particular problem statement of automating site inspection within construction industry. And to build upon the problem statement, we not only wanted to automate the process, but also wanted to test the potential of the technology that is at hand. So let us dive into the presentation.
The site investigation in India includes, depending upon the size of sites. If the site is big, then the entire site contouring and surveying is done. And then the second point comes the preliminary investigation of the soil. Then we do the lab analysis. In lab, we do the analysis of entire soil levels, and then the detailed report is prepared. Present risks involve that mostly in India we are doing the manual kind of boring and surveying. There is a hazard of fall, and if doing by boring is done by tripod, then there is a chance of getting injured or something like that. There are hundreds of parameters in geotechnical surveys to decide. As of today, we should go to some automation.
Great. So as described by our domain expert, the present process of site investigation for construction consists of 4 major steps: reconnaissance, preliminary investigation, followed by a detailed investigation, and finally a site investigation report generation. The present process is tedious, takes about 60 days for an average site investigation process to be completed. It's extremely complex because of involvement of more than 250 parameters, and because of a lack of standardization across industry, it often leads to inefficiencies and monetary losses. Talking about the industry overview, the Indian construction automation market has a potential of $7.1 billion. Out of the total construction companies that we are talking about, 91% of them are willing to adopt any sort of automation and are willing to pay 5% of their revenue. This brings to us an untapped market of close to somewhere around $320 million.
So now let us look at the solution we provide to the problem. We do a two-step approach for this problem. First is the initial inference. In this, given a latitude and longitude of a site, we retrieve 50 plus parameters, feed it to our Bayesian network, and we provide the initial risk analysis. So the data is got from sources such as Google Earth, SoilGrid's API, World Bank API, etc. On the right, just for demonstration purposes, we have used 18 of these parameters and formed the initial causal inference graph. So you can see that in this graph, there are some parameters which directly affect the decision, while the others do so indirectly. Now, what are the advantages of step 1? First, it provides an initial insight to the potential risks. It eliminates the unsuitable sites, and it saves on the cost of inspection for the physical inspection. Now, coming to the in-depth inference, in this, the builder actually goes to the site. He does the surface and subsurface investigation and gets the lab reports and feeds 270 plus parameters across 20 categories to the Bayesian network. And then we get the risk analysis of this. So in this, on the right hand side, you can see the causal inference of 76 parameters. So as you can see, it's a very complex relation, and many parameters directly affect the risk and some do so indirectly. So for the sake of inference, we have categorized this into 2 parts. One is the intercategory causality. So in this, basically, each category has 10 to 12 parameters. So we find what causalities are there between these categories as well as with the risk. So this is one, and the next one is intra-category. So inside these categories, how are the parameters related to each other, as well as how they affect the risk. So for example, here the climatic parameters causal relation is given, and here rock and soil type is given. Rest of the things can be found in appendix. So let's go through an example scenario. Let's say a builder wants to choose between these three locations. He just gives the coordinates of these locations. According to step 1, we will get a risk score between 0 and 1, which is mapped to 0 and 25, which is the standard risk scale. Using this, the builder can reject site. So for example, he rejects the first site because there is high risk of construction here. Then comes the step 2. So in this step, basically he goes to the site and gets all the 270 plus parameters. Once we get this, we again get a in-depth analysis of the risk involved, potential recommendations, and we can also find the causal inferences for this. So here we have chosen location 3 because the risk score is low. Finally, the end decision variable which we have used right now is a risk score which lies between 0 and 1, but this can be further extended to foundation design, resource requirement, etc.
Great. So talking about the validation of the proposed solution, we spoke to industry as well as academia experts to talk about the proposed solution, and they were very willing for such an automation to actually come into such an untapped industry. So a few excerpts are attached here. Moving forward, the potential clientele for the proposed solution would include bigger names such as Larsen & Toubro, Tata Projects from the private sector, and ONGC, IRCON, or NPCC from the government sector. Now, talking about the impact that our solution is looking to build, we forecast an annual cost savings of $20 million. In addition to this, an annual reduction in manpower of 250,000. And finally, a 15 million hour annual reduction in unskilled labor. Finally, talking about the scalability and the future scope of the proposed solution, we look forward to expanding this solution to different types of construction projects, not only limited to the conventional, commercial or the residential projects. In addition to this, we also look forward to building through a sustainable approach and also having architectural recommendations being made through the recommended solution. And finally, improving the present as well as the past foundations. This is what the scalability and the future scope of this product looks like. So with this, we come to the end of our presentation. Thank you very much. We are open for questions.
Vishal, you can start.
Yeah, I mean, is there a standard audit report that has to be produced when a consultancy agency or anybody does a site inspection? I'm just trying to map to say in the field, can this decision making actually help there also?
Within the field,
in site inspection paradigm per se, is there a requirement from authorities that you actually have to give the report so you can audit that it actually happened?
Yes, so this actually happens to be a necessary step for every construction project, starting from a small residential project to the ones that are actually taken up by the government, for example, the dam ones, to actually test whether the construction project that has to be built there would be suitable in terms of the bearing capacity, the soil strength, so that there are no future risks that are there. Answering your question, there has to be a standard report that has to be prepared that includes all of these parameters and actually tests whether the anticipated construction would actually be able to take this up or not.
And is there like so what I'm trying to drive at is, let's say when you apply for credit, right, through a loan or whatever, you have something called a CIBIL, which means you have a standardized way for that industry to say, how would you say this is good, bad, ugly, right? Your profile. In a similar sense, if you were to do a site inspection, is there a standard that exists today that says, these are the parameters that I need to adhere to? Automation obviously will help me do that because, producing a report which is auditable is one thing, but also be able to call some set of APIs that say, okay, there is a solution, put in your parameters and you'll get a very standard report. I'm just asking, in the field, does something of this exist today?
Yeah. So this is an example of the site investigation report, which is generated after the site inspection is done. So these are if you're asking for the standard list of parameters which they use currently, this is what is used. And we will automate the analysis of these parameters, which is right now done manually.
Got it. Thank you.
So basically, we can come up with some kind of a score also, right? I mean, because like Vishal said, like we have a CIBIL score for, credit or financial, industry, right? So maybe,
So
so there is a, I think, yeah, go
yeah.
ahead.
So basically, we have used the risk score. We got a score between 0 and 1. This is the probability of the risk in that. And we have mapped this to a standard scale between 0 to 25. Like 0 to 6 means there's low risk. 7 to 12 means it's moderate risk. Similarly, there is substantial risk and unacceptable risk. So this is one thing which we have shown in our model. So this is one score, and further extensions can be done for other things such as foundation design, construction methods, slabs required, etc.
Okay. So right now, I mean, what you've done is only for the site risk, right? Or site investigation. But
Yes.
after that, I mean, once somebody constructed, right? I mean, so then it will be also applicable to that construction, right? Because based upon, like you said, what is the depth of the foundation or technology use or whatever, right? I mean, there could be hundreds of, I mean, that's, I guess, more complex, right? I mean, how do you actually rate a, or assess the risk of that construction, right? Is it right?
To understand your question, you're asking once the building is constructed, then the risk analysis, you're talking about that, right?
Yes, yes.
To answer that, so first, before building, if the foundation and all are set right, then so that part we are trying to automate. So once the building is constructed, then the current, whatever the maybe the current state of the building is there, we can maybe build another model for that to see give the risk analysis in real time of the building once it is constructed. Such a model is possible as an extension to this.
Yeah. Exactly. I think that will be, I think, a lot more valuable because right now the way I see is that normally we do this, site inspection or analysis or investigation, yeah, whatever report you're saying, just to satisfy the, authority or regulation. But after that, everybody forgets, right? I mean, most of the disasters in India is happening because, we don't, consider the risk in our regular maintenance, right? So if there
Definitely.
is
So
something like more real time, right? I mean, which is actually taking care of the whole life cycle of that, building based upon all the parameters which were captured, before the construction started and during that phase, right? Because right now, I don't think there is any single repository which actually can store all this historical data. I mean, whatever data exists, I guess it exists on papers, right? For most of the constructions, it's actually not digital, right?
Right.
So it's actually a scope to digitize everything and and keep it for the whole life cycle and keep highlighting the risk based upon all these factors.
Definitely.
Okay, good. Thanks. I think no more question from my side. Thank you.
Okay. So we'll begin with the next team. Team 61. Are you ready with your presentation?
Yes, ma'am. We are ready. Just we are sharing.
Yeah, sure.
Is my screen? Is our screen visible?
Yeah, your screen is visible. The buzzer will be played at 2 times, the 3.5 minute mark and the 6 minute mark. You can start your presentation.
Okay, ma'am.
So we are starting. Good morning, everyone. Our team 61 is here to present a model on the easy automation of complex decision making. Let's discuss the problem statement first, which we are going to solve. Choosing a career is a critical decision that will significantly impact a person's life. It's a complex process that involves considering various factors such as personal interest, skills, values, and financial status. Making the right choice can mean the difference between a satisfying and successful career and the one that leaves an individual feeling unfulfilled and unhappy. One of the challenges of career decision making is the vast array of options available, making it difficult to know where to start. Additionally, the traditional career selection process can be time consuming and resource intensive, requiring individuals to conduct extensive research, attend career fairs, and reach out to friends and family members for advice. This is where automating the decision-making process comes into play. Automating the process of choosing a career can provide more informed and personalized recommendations, reducing the risk of regret and increasing the likelihood of success. This can be achieved through the use of advanced algorithms and data analysis, which can take into account a wide range of factors, such as personal interest, skills, financial status, to provide tailored recommendations. So now let's discuss why career decision making requires automation. It requires automation for several reasons. Like firstly, the objectivity. This system can remove personal biases and emotions from the decision-making process, providing a more objective assessment. Secondly, the personalized recommendations. It can analyze multiple parameters and provide personalized recommendation based on students' individual strengths, weaknesses, and aspirations. Thirdly, time saving. It can quickly process large amounts of data, saving students time and energy. Fourthly, the improved accuracy. It can use sophisticated algorithms to provide more accurate and reliable results. Fifth, the reduced risk of regret. It can help students make informed and objective decisions, reducing the risk of regret and increasing the chances of success. Sixth, the accessibility. It can be easily accessible to a large number of students, providing equal opportunities to everyone. Hence, automation can help make career decision making process more efficient, accurate, and fair, providing students with better opportunities for success and happiness.
Now, what are the factors that affect career choices? These are the primary factors that we have listed. These factors play a major role in deciding the career path for students. Our model will classify the input given by the user according to the data we provide for those factors. The dataset for the factors can be found by the surveys conducted by different organizations, but further improvement can be done in that. Following the decision, it will generate the best possible career.
You're not audible.
Yes, because host has muted the participant.
Okay, okay. I think it was an error. You'll get more time to do that.
Okay, fine.
There was a lot of echo coming, I think.
Oh, oh, okay. So now I'm continuing. Am I audible right now?
Yeah, you're audible, and please, the other team members should keep muted. There's an echo.
Okay, sorry. And please continue right now. Okay. Following the decision tree, it will generate the best possible career path for students. The factors listed are in the priority order of their importance for determining the career choice. Now, the model will provide personalized recommendation based on student individual strength, weakness, aspirations by using combination of data, algorithms, and machine learning models. The model will collect data from multiple sources, including self-assessment, which includes personal interests, skills, values, and goals, career exploration, information about different careers, institutions, high school performances, grades, major subjects, subjects with best grades, etc. Personal characteristics of students, memory capabilities, disabilities, allergies, phobias, etc. Career aspirations, expected working hours, job security, professional prestige, and etc. Next, here is the model of how different parameters are linked and how some are dependent and independent to others. This is a much simpler model for beginning as this affects their probability of choosing the right career. Next. In conclusion, the career decision-making model is necessary as it provides a comprehensive and objective approach to the complex decision of choosing a career. With the increasing competition in the job market, students need to be well informed about the career chances and opportunities available to them. Using data and algorithms, we ensure that the recommendations are based on objective analysis rather than subjective opinions. Overall, the decision-making model is valuable tool that will help students to make informed decisions for their career. Also, the career decision-making model startup has a potential for success for several reasons. Firstly, the demand of career guidance is increasing as the students are facing growing competition in the job market. Secondly, the model provides a unique solution for providing personalized recommendation based on objective analysis, which sets it apart from the traditional career guidance method. Thirdly, the use of technology and machine learning ensure that the model is efficient, accurate, and which will attract the users. Furthermore, the model can also be scaled and used in different regions and countries, providing a wide market for startup. Additionally, the startup can generate revenue through partnerships with educational institutes, career counseling services, and job placement agencies. Thank you. Now we are open for questions. Hello.
Vishal, you can start.
Yeah, I'll ask a very open-ended question, and please give me your answer based on how you think. Is this a career decision thing? But do you think we have enough data points to be able to decide based on a Bayesian kind of an approach, or is more of a what's the market demand driven kind of an approach?
Sir, can you repeat your question? I don't get that.
Am I audible?
Yes, sir. Yes, sir. You are audible. I don't get
Yeah,
your
yeah.
question.
So I'll repeat the question, or maybe qualify the question more. So what I mean is that so let me ask it in a model way then. Do you have parameters there that actually take care of the market demand?
Sir, according to us, the parameters we are suggesting will definitely take care of the market demand. Actually, people do think more about more than these parameters, but by considering these parameters also, we can give them a personalized recommendation, which will somehow give them an idea that yes, that I can do this path, and it relates to my field and what I am doing, what are my interests, what are my skills. So I think that these parameters will be. I definitely agree with you. There will not be sufficient parameters to choose a career, but I think these we have to limit somewhere, and these parameters can give some better results and career decision options.
Do you think if I need information, then I can go with the bot, which simply just give me information around multiple things, right? I'm just trying to say, are we taking an approach wherein we're saying we need information to be able to make an informed choice, or we need more of
Definitely, we need some of the student
directional guidance to say, well, these will be the other factors that will be important for you, so keep them in mind, type of an approach.
No. So it is, this model will be like the student will provide some data, like I said in this, the factors. We will collect some data from the student, and this model will provide them that yeah, these are the chances that this you can succeed in these particular career options. So it can give him a motivation that yes, I have these particular options and I can move forward with these kind of skills. And yes, that's what we are approaching.
Can this work in a reverse way also, wherein I say, well, this is all I am doing, right? Or maybe this is what I want to be, and it guides me to say these are the things that you should pursue.
So we can definitely work with that also. But for that, we have to collect separate type of data. Like one people who have become, we have to collect data from them, what are like, what they are like. Although I know that will not be always correct, but it can give student that what they want. Like every student clearly want to know that what they should do to become like that. I definitely agree with you that student needs that, and yeah, we can make such model, but we have to we need data from a different type of audience.
Thank you. That's all. Anush.
Yeah, nothing, no question as such, but yeah, I think this is the most complex decision, I would say, right? I mean, career choice, and it's very subjective.
Yes, sir.
So, yeah, I mean, you had actually had the opportunity to go really into the depth of this subject and identify various parameters, which I think is not very easy to identify. You need to actually
Yes, sir. Yes, sir. It
talk
is
to
not
multiple
good.
counselors. So I don't know whether you have actually spoken to any career counselors, right, or not, and try to put a science behind this uh, complex and subjective decision, right? uh, but I think, yeah, this may require more research, and because this, I think maybe 10 days is not enough to
Yes, sir.
really go deep into this subject, right? It's actually
Yes,
it's a
it's a
very
very
I would
deep
say relevant,
domain to
use
collect
case.
these
It's a very good
metadata.
use. Yeah. Sorry, you were saying something?
Yes, sir. It is a very deep domain to collect this metadata. We have to require serious research and all that.
Yeah, exactly. I mean, so I think the problem was very relevant. The use case was very good, and as I said, it's very fit for making a decision model. But maybe it requires more research, and you have to maybe continue to work on this to actually take to the level
Yes,
where
sir. We
it's
can
actually
like develop it over years,
feasible.
and
And
it can be precise over years.
yeah, exactly. Yeah, exactly. Anyway, but it's a good start. I think good topic. I say. Thanks.
Thanks.
Thank you, sir.
Any more questions, sir?
No more questions.
Okay. Thank you, sir.
Okay, so thank you, team. We can start with the next presentation. Team 23, are you ready?
Yes, we are ready. We're sharing the screen.
Okay, sure. So there'll be two buzzers, one at the 3.5 minute mark and one at the 6 minute mark. So that's all. You can start your presentation as you're ready.
Okay, can you give me a minute? Can you share the slides on your screen? We're sorry, I can't share screen. Is there a problem? Like, I have not been given an access. Yes, it's sharing now. I'm able to share. Oh, wait. Okay, cool. Pass me the laptop. So we'll start right now. So the corporate sustainability advisor, the easy automation of complex decision making we're trying to do. To understand the problem statement, let's try deep understanding of what sustainability is. We consider sustainability as a parameter we're trying to save the earth. However, sustainability should be understood as something that helps human protect their space on earth. Sustainability has three pillars, namely environment, economy, and social. And the gray area between them is sustainability. This presentation is a special emphasis in the social part of the sustainability. Will you consider a hand-woven, organically grown shirt sustainable if child labor exploitation was involved? Now, to learn more about the use case, we tried to dig into the experts into the field. We were lucky enough to get Professor Kent on our call. He's assistant professor in climate change at Dalhousie Uni in Canada, where we talked about sustainability. He emphasized the quantification of the 17 SDG goals and answered mainly yes to all the questions, saying whether there is in demand, whether or not it could be used as a financial tool, or should we make certain advisor or not. We also talked to Professor Arpita Pandey. She's an assistant professor at IIM Bangalore, where she emphasized heavily on the fact that we need to use the existing SDG parameters in the industry to make an automated model of it. She highly emphasized the fact that we need to use data and data itself, and because there is a market demand, but there is no good automator. So building the blueprint, we have had millions of parameters that could have affected our company's corporate sustainability index. but the 17 SDG goals are primary one. Even though 17 SDG goals are super subjective. So we came up with a mathematical method of how are we going to analyze which parameters to use. The Delphi method is a mathematical object that selects a few of the parameters depending on a choice of things. So to understand the model, here is a small part of the decision tree that we've made. Although this looks super complex right now, the day we were making, we just had 1 or 2 parameters in the graph. So as you can see, there are various types of inputs that we can put into. There is Boolean, and there is even the fact that we can have normal distribution Gaussian things into the sample environmental impact model. Now, this model helps all of these parameters comes together and says an environmental impact of the entire sustainability model. These smaller impact models then combine to make an entire sustainability concept model at the end. So to analyze more, we also created sample models for we also created sample models for the social impact, which had certain different parameters such as transparency and white space, like security, health, employment details, and practices. Also for environmental impact, we had listed a ton of these parameters that could be helpful. Also, they are well documented in our report that we submitted. So these parameters together club together and give an impact, a sub-impact score that together combines and gives the final sustainability score. One of the thing is the maths behind the model. So these parameters had to be connected within each other. The noisy OR operator tells the relationship between the true Boolean parameters and gives the end decision parameter they're effective. There's enabled nodes. There are certain parameters whose information is widely available on the internet. It comes in form of research or like even mentioned, the SDG goals. Everything, please do keep this data on. The next is propagation analysis, how one node goes to another. There's also the sensitivity thing where a change in a specific parameter also changes other things in the network. The carbon offset risk is one of our feature of the model where we try to say that this is the how sustainable was your carbon offset risk, such as companies do sell their carbon offsets to get into the industry and say that they're greenwashing or carbon trading. There is also a white parameter where companies are judged onto, starting from AAA plus to A, where you can tell how a company is more sustainable. Now, carbon credits made Tesla super duper profitable, not by selling cars, but also because since they sell electric cars, they also sell their carbon credits to other companies who are then allowed to make pollution as much as possible. Our emphasis until now had been onto the social impact of it, but we also want to mention the entirety of the fact that the process is also as important as a product. Now, construction of the decision tree happened through this pipeline where we selected we select the parameters, then we made a network out of it, then we collected data through research papers, analysis, internet resources, the existing data on the internet, and then we tried to analyze the output. We have 6 different types of decisions that we can make out of this, and it all depends on the fact that how sustainable a company can grow. And this is, I believe, since we are in sustainability practice advisor, this is where the whole math comes on to. This is the final decision tree that we have at the moment, where all social, economical, and every different thing is clubbed together. How can we become an advisor is one, we give a score, ultimate sustainability score, having social, economical, and other parameters, but also our AI model can retrack and go back to different of these nodes and select an optimal route where they can reduce their carbon store. Instead of just telling you what your carbon score is, they can also say, if you change it, if you alter the route, you might change your sustainability score. Because if a company is going through a specific risk module or a specific type of legal regulation, you can either change the location or everything. So such a thing is also possible in our model. Another thing has to be noticed is the outer parameter of the entire sustainability scoring system tells the true cost of sustainability, from the risks involved to the social impact, the social diversity at the end. To say that the final recommendation would be that such a scoring system will help companies realize that sustainability is actually a financial tool. It's a well-documented thought, and educating this will help us achieve equality and inclusion. Thank you. We are open to questions.
Vishal.
Yeah. So, Rohan, the question I had was more around uh, this is pretty important area. Carbon credits and a way to be able to trace where you can actually take care of that is also a good thing. I'm just thinking, is this something that you can map to say, does it lead to optimization or profitability anywhere? Or is it just is it means to an end, or this itself can be an end?
No, it leads to end. So, like even with when we were having conversations with our experts, they did say having a score would help realize in the competitive market where do they stand, which makes them take decisions at the end. And since it can also recommend which path to take, it will help businesses. Like corporates, we're not even targeting the big corporates. We also want to make sure that even smaller businesses also come into the play and they start having sustainable practices within. Also, the fact that it's well documented and well proved that following sustainable practices is profitable for businesses. So what we can tell, having educating people and having a score which they can compare with will help them achieve better financial growths.
But does this apply across all set of industries, or where you may not have a direct but more an indirect contribution to the carbon credit
I
and other things?
I believe every industry has a carbon contribution on it because every industry uses transport to get to one position, uses the internet to use our laptops or charger, or even takes calls up. So carbon is something that's used everywhere. More than that, sustainability is not just limited to pollution. It is also the human cost. The entire fact of social inclusion is completely ignored when we talk about the carbon offset. So saying sustainable practices is just for certain carbon polluters will be wrong, because sustainability is a concept that goes across all the industries and every possible businesses.
Okay. So if I understand, I mean, sustainability is a bigger umbrella and carbon credit is just part of it, right? Is that right?
Yes, and our model takes care of it.
Okay, and your model anyway take care of the carbon, right? Good. So one, I mean, 2, 3 questions. So one is this model going to be specific to each industry, or this model will be generic enough which will take care of all kind of industry? For example, if I'm giving a score, right? So is a score in a, let's say, petroleum industry may be different than clothes or whatever, right? I mean, so finally the model will be industry specific model. So we'll have multiple models taking care of each type of industry, or will there be one model?
I believe just a single model, because our model, let's say if a specific industry is not being a carbon polluter, then the input on the Bayesian network will be zero, which means at the end it's not contributing to the pollution impact. So it's irrespective of the industry. It goes, because the input has to be put by the businesses. If they're not polluting, it doesn't count as a score. So it's irrespective of the industry.
Okay. Second is, do we have a rating agency for this? Like, because we can come up with a technology solution, but end of the day, to become credible, or I mean, like, you have all these rating agencies which actually give rating which adds to the credibility, and that business can go and advertise that, look, I am rated this much on sustainability, right? So do we have any agency anywhere in the world which actually does this kind of a rating or scoring?
There are certain of these businesses, and like this question, we also had this question. We asked Professor Kent about it, and he said there are industry, but businesses, they don't let these industry grow up. UN is trying to build up a model out of these 17 SDG goals so that we can form across all the spaces we have. But to this question, the answer is yes. We even had carbon frauds. To be honest, like in financial markets, how we have these stock frauds, we also have carbon trading frauds in 2008, very recently too. So there are agencies who does the exact same thing how financial markets do. They bundle up bad stocks together and they sell it to the companies. The carbon off trade and the risk part that we've covered in our presentation too. So there are industries, there are rating system, companies can follow them. It's just that companies need to realize that sustainability is an actual thing, like they do with the stock trading. So the answer to that question is yes.
Okay. One last question, right? I mean, were you working on this topic before this event, or I mean, it's like, are you want to continue to work on this, or this was just for this event purpose, right?
Sustainability is something I'm very close to. It's actually so. I've been at UNPRME because of sustainability. I am going to work on sustainability even after this. So I thought it's the best to do is make something technological out of it. So our team is onto sustainability.
Okay. Because I mean, the platform, I think we didn't expose you to our platform, but on the platform we can actually build these kind of models. So maybe
We were
we can offline.
testing the model. Actually, we even texted the organization for giving us the access so that we could have made something, so that we could have shown how a company is feeding the input and the output. Because the models that we've shown in the presentation are also in some sense functional. It requires a lot of tweaks and changes to see how each of these nodes are changing. But if we had a software, it would be really, really nice so that we could have shown how we are imagining the sustainability advisor.
Yeah, exactly. Because our platform, you can actually create a model very quickly, and it generates a chatbot also on its own, so that people can give input, and at the end of the day, it will give you a score, right? So it will be a good demo to build actually. Okay, maybe let's connect. Okay, thanks.
Okay, thank you, team. We'll move on to the next team, that is team 25.
So hi, are we visible and are we audible?
Yeah, you're visible and audible. I think
Yeah, I'm just sharing my screen.
Yeah.
So is my screen visible too?
Yeah, your screen is visible.
So hi, good morning everyone. We are team 25 and we are working on the domain of solving the pending jury cases. So these are the basic contents that we will go through this presentation. So firstly, to start, the use cases revolve around the decision complexities, alternatives, and the uncertainties. So the three major entities that are involved in the decision-making process in the judicial system are the judges, the lawyers, and the parties that are involved. So majorly the complexities in decision lies because of the differences in our country, and it becomes a very time consuming process, and it becomes very difficult to extract information from the redundant data, and also and to make sense and correlation between all the data present with us. So next important point is choosing among the alternatives. So whether or not to take a particular matter into the case, and how quickly the dispute should be solved. Does the case needs one more hearing or not? And thirdly, it is the uncertainties, like the compensation amount is worth or not, the odds would be successful in your favor or not, should the case be solved through an arbitrator, or it should follow a proper legal proceeding. So the model basically that we are formulating is not replacing complete human intervention, but it is helping the courts to ease out the process. So in presently, the scenario that we are seeing in the system is that we have 10.8 million pending cases in the civil litigations, 43.4 million total cases that are right now present in the district and the taluka courts of India. There could be various reasons behind this, that is the corruption in the long trials, the lack of the transparency in the system, less occupancy of the jobs in the system, lack of the public awareness. So basically, these for the solution, the major backbone for the solution is the Indian Contract Act of 1872. It provides a comprehensive guide for all the promises that are made between the two entities, and all that is formulated and provides for the steps that have to be taken in case those things are not considered or breached.
So it basically has two parts. The part 1 deals with the general principles of the law of contract that lies from section 1 to section 75, and the part 2 that deals with the special kinds of contracts in which there is like the contract of bailment, the pledge of contract of agency. So this is the major overview of the Indian Contract Act 1872. So basically, our model is solving real life cases that show the implementation and enable us to reduce the turnaround time. First is the prioritizing the cases on the outcome of the probability, how much time it would take for a case to be solved. So it gives the high case completion rate, less number of cases per judge to be involved in the future. And the second is the eliminating the possibility of any sort of inherent bias in the judges. Though the judges take an oath to be impartial towards any entity, still this would prevent the inherent bias in the judges.
So here we will like talk about the transformation approach. So basically three approaches are taken while considering this model. First is the linguistic approach. Like many times the uh, documents can't solve all the problems. Like the semantics also comes into the approach of the judge. So this thing is taken into the consideration in this model. The second thing is the legal approach, where the factors or like the features are extracted from the legal document while making it in a proper format in which can be used for the AI model. The third is the political science of the social science approach, in which the factors such as human bias comes because of the gender or the class of this of the petitioner or the defendant. So here, these are some of the parameters that we will be taking into the account. So first is the defendant, which is basically the past history of the defendant will be taken into the consideration. Or the second thing is basically the priority is given to more to the plaintiff side. So here, these are the rhetorical roles, as you can see, where the facts ruling by the lower court, argument, statute, precedent, and the ratio of the decision will be taken into account, as these are the categorization of all these parameters here. So now this is the process and the prediction analysis. So first we will take inputs, then process, then output, then decision. So in this input we will first take all the database. We will make OCR of them, like we will extract the data, we will video feed it, like we will make the sentimental analysis of the videos. We will process this, we will extract the features, we will make these inputs process, we will also normalize it. The third thing is the output, as we already know that these are given on the basis of the Bayesian. So the probability will be provided to us. So the probability is in which the probability is the side on which the probability is much higher, that side will be given more preference, and the decision will be made according to that. So this is the sample judgment, as you can see. So here all these are the things that we also can see that our model can extract, or it can take into account. So here we will finally come to the conclusion, where the prediction of the outcome of the civil cases will be uh, we will get the prediction of the outcome of the civil cases, and the relevant factors and the parameters have been considered in this AI model. Moreover, the foundation for the approach of the problem is taken into the consideration.
Thank you. We are now open to questions.
Okay. I think again, this is a very good topic. And again, one of the, I think complex, right example of a complex decision making. I mean, my first question is actually, I didn't get the clarity that are you really talking about Bayesian network to, drive the probability, or this is more based upon typical, machine learning, deep learning, where based upon the historical data, you are trying to, predict the outcome, right?
Okay.
Because I didn't see actually a right example, that how or what type of a Bayesian network and I mean, the parameters which you mentioned are more suitable to predict, like you said, the duration of, the case. I mean, how long or, or effort which is required to do that. but give me some examples on the basis of which we can actually create a model which will give the probability of winning.
Yes, sir. Actually, the first approach that we are using is the prioritization of the cases. So here, what we will do, here we will like input all the the hearing will be done, and in parallel to the hearing, the input will be taken into this model, and model will be processed. So by the time, what will happen, during the course of the hearing, as the hearing as the dates comes, hearings are being processed, so the model will also get a lot of data, and when it hits a certain bar level now, then it will obviously this will input will as your model is, it will take input, process it, and provide the probability. So here, when the probability will hit a certain bar, let's say I don't know, maybe it can happen that your model can give a bar at 90% accuracy. So let's say when it hits the probability at 90% or 80%, let's say, so then the judge will give extra time to that particular case to solve it. So here what will happen, the normal hearing of the court will not be disturbed, whereas an extra time will be allotted to that particular case. So what will happen, it will the case completion rate will be increased. Moreover, that particular case will have more chances of solving early in the time.
And so one more thing to add to this, as we were majorly focusing on the IT industry's contract breaching cases. So there were two major cases. That was the Fatehchand case, and second was the NRC software case that was between the Assam government and the Wipro. So taking in consideration these two cases, we have formulated that what could be the how the model would be actually be working, taking in all the parameters, the legal documents, the previous reports, the expert opinion of the committees, the witness, and all these things, and different weightages would be provided to all depending pertaining, and the weightages would be different as per different cases. So from these, the input would be taken into the model, and depending on the weightage that is provided and the data that is accumulated in the model, and as the model keeps on learning with addition of the new data sets, so from there it would work in coherence with the judge, and the result from the judge's end and the model's end, if they matches at a particular range, then we can say that from the judge's end also there was no like bias or something like that, and from the model also it is giving a better probability, like how many hearings we can predict this case would linger on for.
Moreover, for if we talk about sorry.
Okay. I think, yeah, again, I mean, I still have more questions, but maybe right now it's good that, that's what you have put. But again, my, I think feedback is that, yes, this requires possibly more work. Maybe we need to, come up with, like you said, models which are specific to particular type of cases, like you said, IT, contract disputes or cases, because this field is so complex, and there could be thousands of parameters, but those parameters could be very specific to each type of case, right?
Yes, sir. Even when we contacted like Professor Kripa Bandhu Ghosh of IISCR Kolkata, he has his expertise in AI in the legal domain, and we have contacted Judge Suhasini Vashisht, the judge of the High Court of Jammu and Kashmir. So it from there, from the ground level perspective, as we thought of working on the grassroots level, so it said it was like came out that these for every different segment there has to be a different data set and different model, so based on that they have to give the judgments, as every case is different and pertaining to the domains also a major broader aspect has to be considered.
Got it. So yeah. So thanks. I think I got the Vishal. Any question you have?
Well, no, I think you the team did address in a very roundabout way, but let me get straight to the point. Very promising field, but I think we need a proper solution approach to it. I do understand that there is a methodology given here, right? but the decision-making methodology is fine. More details can be thrown in.
Sure, sir.
Yeah, that's all from our side. Thank you.
Okay, thank you, team. We'll be starting with the next team. That is team 27. Are you ready, team 27?
Yes, we're ready.
Okay, so you can start your screen sharing. There'll be two buzzers, one at the 3.5 minute mark and one at the 6 minute mark. And you can start.
So good morning, everyone. So the topic we are working on is quality control. So India is on the path of becoming a global manufacturing hub, and it has a lot of potential. So even the estimated export is around $1 trillion by 2030, and the manufacturing sector holds a prominent position in the Indian economy as well. And coming to the global scale, the global manufacturing industry is booming, and it now accounts about 16% of the global GDP as well, and about 14% of the employment. So, and henceforth, quality control plays a critical role in the manufacturing industry, and it holds a lot of significance as well. And it helps to ensure that the products produced and manufactured meet the specific requirements as well, and are free from defects. So, considering other aspects as well, like the customer satisfaction, uh, or be it legal compliance or the consistency of the product, or the continuous improvement, which you speak of the total quality management. So considering all of these aspects, quality control is an essential aspect of the manufacturing industry, because it helps one to ensure that the products are meeting the quality requirements and the customer expectations, and are produced in a cost effective and in an efficient manner as well. Moving on, so we have focused specifically on drift here, uh, because again, drift. Let me explain what is drift again. So, drift is the deviation of the process from the desired setting and performance parameters. It's like we set the lower control limit and the upper control limit, considering the Six Sigma limit. And when we say that a specific product is getting out of the control limits, then it has drifted away from the process, which means that it is defective. And there are control charts and the statistical process control as well, which has statistical methods to determine what are the control limits, and uh, to set up that lower control limit and upper control limit. So, and like the science of drift are, often subtle, and like it holds that significance. Like if a product is getting drifted away from the control limits, then it more tending towards that it could be defective, So, and in the drift, in these sorts, like drift influences the quality control as well.
So moving on, let's see how what decisions we can automate in quality control to prevent drift. We have found many of the decisions, like we had statistical process control. Here we use statistical methods to monitor production processes and identify when a drift in quality occurs. And we have anomaly detection. Here we use machine learning algorithms that can use to identify different patterns in quality control data that can be used for early detection and drift in quality standards. And we have predictive maintenance of equipment. Here we can use predictive maintenance algorithms and identify when a maintenance is needed on missions and even in the production processes. And we have quality metrics tracking. Here we can track the key quality metrics like defect rates, first passing and mean time between failures. Among these we found that we had a complexity in calculating drift and maintenance cost of different products, and we chose that as our final decision or output for this. And we have like the primary audience for this is the quality manager. Like quality manager has not to there's no need for him to wait for the final product to be completed and see whether the product has drifted or not. In the meantime, he can use the charts and find out and calculate the drift score using different algorithms. And we have taken about 68 parameters which are of Boolean and categorical type, and predicted whether there is a drift in the product. Few of them include like production conditions, environment data, etc. So
yeah. So here we have identified like many parameters which indeed influence drift and maintenance. So based on that, we will estimate what's the drift score and what's the maintenance score. That will help the quality manager. Indeed, like it will automate that decision of whether a product is moving towards the control limits and whether it's out of the control limits, and whether a particular equipment needs maintenance at a specific time, because that's very important again, because if it is not maintained properly, there's a lot of chance that the process may stop, or indeed like it may result in more defective products as well. Thank you, and we're open to questions.
Vishal, you can start. Vishal, you want to start?
Sorry, on mute. I have a similar question to the one I asked. Predictive maintenance is a very machine learning, statistical driven field.
yeah,
And that, so I'm not saying this is predictive maintenance, but this is like, that's one of the approach to really be able to measure MTT values and other things. Now, I'm like, is this really a discrete kind of a decision making, or it's more about because do you believe this will actually, the decision making actually needs to be done by a Bayesian kind of an approach? Let me keep it.
Yes, sir. So to answer that, like there are certain parameters as such, like regarding maintenance specifically, if we can talk the disposal cost and the repair cost and the maintenance cost, and what was the earlier maintenance that has happened, and what it is again very, we can be very specific about it to a specific manufacturing process as such. So considering all these parameters, then like we can arrive at a maintenance score, whether to see whether like particular equipment requires maintenance at that point of time, or when does it require.
And I would assume that predictive maintenance is an advanced function of that thing, to say all the equipments have their maintenance schedule, right? So for example, let's say a car has a maintenance schedule that every year or maybe 10,000 kilometers, depending upon the car, or say it may be a little less in some cases. So they have the schedule. Predictive or preventive maintenance is probably going to tell you that while you may go for a schedule, if there's going to be unscheduled breakdown, then it can predict that. And it might as well tell you which part may lead to failure based on the data you've been reading. So that's the approach. Now, as I said, that's why in my mind I'm just trying to say there is a definitely a machine learning approach to it, to really come out with a factor, to say a discrete factor and say, well, are we doing good, bad, ugly, right? When you take that input, what you're saying is you take that input and say whether you need to really act on it now, or there is a chance you can still carry on with it before there is too much of. Is my understanding correct? I'm just checking it.
sorry, sir.
No, I was saying, is my understanding correct? As in,
yes, sir, it is.
When you take discrete output of some of this thing, let's say even machine learning, and you say before the drift goes and affects your quality really, really bad, you still have a way to be able to decide whether I need to act now uh, uh, or I can wait for some time. Is this telling me that kind of a thing?
Yes, that is essential a part of it. Yes. So like through drift, we'll see whether like whether it like basically from through the charts we'll see like whether the process lies within the mean or it is drifting towards the control limits or after the control limit. So essentially, yes, that's what we'll arrive at.
Yeah, and that's why this question that I had initially to say, because we would want to have a limit as soon as we put a range to ourselves, right? The range can be dealt by a decision which is more of a rule-based engine as well, right? To say whether it is above this or below this, there is trouble, do something. And that's why I'm trying to map when you propose this solution, is it giving me anything beyond that? Is it, or is it telling me? Is it telling me that when the drift starts to happen, you may not have reached the upper limit, for example, where the trouble is there, but it tells you that you're on the way ahead of time, maybe a positive or a negative way, and then gives you that, because most of the instrumentation is done for upper and lower limits, not the drift actually, right?
Yes.
So
Okay,
yes,
I'm just trying to bounce it off to say, am I understanding the solution correctly or not?
yes, sir, indeed.
Okay, okay, I got it. Thank you. Anuj, maybe if you have a question, otherwise I'm done.
Yeah, no, I don't have any question. Thank you. So we are done. Thanks. Yeah.
Thank you, sir.
Okay, thank you, team. We'll move on to the next team now. The next team is team 21. So, are you ready with your presentation? Is team 21 here? Okay, so team 20, I don't see team 21 here. If team 21 is not here, I think we'll skip to the next team. Team 51. Okay, they're not here either. Team 13, I see you're on call. Are you ready to present?
Yeah, can you give me a minute?
Yeah, sure. You can take
Yep.
a minute.
When you propose this solution,
Just give me 10 seconds. We'll share our screen.
Sure.
Team is Team 21.
Where is team 21? So team 13 is presenting, right?
Yeah, we'll do.
Okay, cool.
Okay, just give us 10 seconds. We'll get the screen started.
See Team 21 here.
Can team 13 present?
Yes, please go ahead.
If Team 21 is not here, I think we'll skip to the next team.
Can you please mute yourself? I think there's an echo coming from the live stream.
Okay, we'll get started. Hi, judges. We are team 13 and our topic is the...
Team 13, I see you're on call. Are you ready to present?
Rohan, I think you have switched on your live stream and that is where the echo is coming.
Yeah, can you give me a minute?
Yeah.
Are you unable to see the screen or...
No, the screen is visible. There was an echo coming from your end.
Oh, okay.
Yeah.
Just give us a minute. We'll figure that out.
It's fine now. I think the live stream was on at your end and that's where this was happening.
Okay. Okay. So it's fine now, right?
Yeah, you can begin.
Okay. We'll start in 2 seconds. Cool. Hi, judges. We are team 13 and our topic was task force formation specific to the corporate setting. Just to define the problem, I'll give you a scenario. I'm sorry. Hello.
Yeah, you can continue. No interruptions.
Okay. Yeah, so just to give you the brief about the problem statement, I'll give you a scenario. Let's say you want a team of, let's say, 4 developers, 2 product managers, and 4 business analysts, and you have a corpus of 100 people for each of those roles. How do you pick the top 4 to 4 people for each of those roles such that they operate optimally? We were basically solving for 2 objectives over here. One was to, reduce the effort that is put in by the HR teams and other related teams in actually forming these teams. And the second was to get that intangible benefit on profits.
We'll share our screen.
Sure.
I think there's again an echo from your end from the live stream.
Okay. Yeah, so basically, we were trying to optimize for that intangible profitability that you would get from a better performance in the team, right? We saw the current selection process where the first step is to define the objective. That is followed by defining the team composition. Then there is a basic shortlisting of the candidates. You gather the data by filtering some of the candidates, and finally you select all the candidates. So we saw that the maximum effort and the most important aspect was actually the selection of the candidates. Okay, just give us 10 seconds. We'll get the screen started. Okay, there's a lot of echo. So can we just, go again? Because I think there's a lot of interruptions.
Yeah, that is from your end only. Like everybody else is muted.
Okay. Not sure what is going on.
Yeah, so no problem. I think we are able to follow you, so you continue.
Okay. Okay, we'll do that. Right. So we basically identified that, the selection of candidates requires a maximum effort in terms of the sheer effort and time that is put in. And it's also the most critical aspect. Now, each of these steps has a lot of challenges that are described on the screen. But if you see, the one place where you can actually use statistical evaluation is the last step, which is the selection of candidates. And that's what we chose to go ahead with. Now coming to the model itself, right? We basically had two important points that we were thinking of. The first one is, how do you actually satisfy the constraints? How do you actually satisfy that there would only be 4 developers and 2 product managers? Because generally a Bayesian network would likely to give you all developers or all product managers based on our parameters. So we decided to go ahead with taking n different models for n roles. And the other insight that we got from corporate was that, higher up in the designation levels, there are de facto people who are basically assigned a role. And mainly this problem arises in the freshers and the freshers +1 level. So what we did was we basically define the underlying team, and then we choose the team leads, because most of the inter-team communication happens between the team leads. So basically we choose the underlying team first, and then we choose the team leads. So this was the basic architecture of the model. Now let's go into the parameters themselves, right? We had a very interesting challenge over here. We couldn't find any data because it was obviously confidential for the corporate. So we had to make do with football data from Spain. And we had 4 different categories, which were the groups, the individual performances, the type of task, and the social interaction of the individual. So we were basically modeling these, and we got this graph. A brief overview of the parameters themselves. The task parameters basically define what kind of a task it is and how attractive that task is. The performance is basically the performance metrics that every corporate has. And the social, personal / group parameters, we basically model how a person would interact with the other people in the group and how it would affect the optimality of the team. And for this, we thought of using a clustering algorithm of sorts, where we cluster different people and try to maximize the people who would come from the same social cluster. Yeah, and the next step, once we have identified all of these, was to define a utility. Another reason why we chose to go with those n different models was because we can actually define different utilities for different roles. And for example, on a generic fresher level for a developer, you would want to optimize for individual performance and give 80% weightage to performance and maybe 20% weightage to cohesivity. But for a product manager or a business analyst, where interactions are much more critical, you can give more weightage to social interactions and slightly less weightage to performance. And this can, fine tune the team in a much better manner. The model basically uses states which are defined by the user. So he has to define what is the likelihood of this person being an expert or an intermediate or a beginner. And these are used as prior probabilities to maximize the utility function that is defined. And the utility function maximization basically gives you a list of people who would be in the team. So that is the flow of the model as a whole. And this greatly reduces the effort that is actually given out by, in making these teams.
Right. Now, giving a quick example of where this model can be used is inside consulting firms, as they have teams which are dynamic, and also the task parameters also evolve over time. The current selection process in the firms looks like this. First of all, the HR teams select the unassigned and available candidates, and they also list down the relevant parameters such as billing rates and their past experiences. Parallelly, the partners also recruit the associates whom they are comfortable working with. Next, the HR team shortlist the candidates based on mainly two things. That is their exposure in the field, whether they have it or they don't, so that it's an asset to the team, or they have a learning experience. The partner can also choose to have an interview with the candidates before accepting them in the case team. with our model, the whole process is streamlined, as the HR team can feed in the data into the model, and it would also give an internal scoring, saving them a lot of time, as they won't have to interview each and every individual candidate. And it would also eliminate any sorts of biases that the partner can have towards some candidates.
Yeah, that's our pitch, guys. Thank you. We're open for questions.
Okay, thank you.
So
Thanks for the presentation.
the only question I have, this
Yeah.
this is like finding the right candidate for your squad. You're not choosing the squad.
Can you clarify? I mean, we basically define the composition of the team. So we define, like, saying that we need 4 developers and whatever the constraints are. And the model helps us pick those top 4 people for the role.
Yeah. So what I mean is, choosing a squad is an optimization problem.
Yeah.
Or I would say there are different ways to approach it, but idealistically, it is an optimization problem that you want the most experienced team at the least cost, right?
Sure. So, okay. So
But
I understand where you're
what?
coming from.
Yeah.
Is the question, how is this a sort of a
Yeah, I'm just trying
statistical?
to I'm just trying to clarify my understanding of it.
Mhm.
What this team to say is that if you define a set of constraints, then it gives you the ideal composition of your team. Given that there are certain roles that will be there, it will find the right candidate or candidates that fit that role.
Yeah.
Okay, got it. Take it. Thank you.
Yeah, so basically, just to clarify, the statistical or the Bayesian network part of this basically comes in for the social aspect, right? So we have a certain parameters, and it's very difficult to gauge how each of those parameters interact with each other to form a ideal team. So the Bayesian network basically learns that aspect and gives the edge.
Yeah.
Okay,
I
got
mean,
it, right? I mean,
go ahead, Anuj. Sorry.
yeah, no, shall you continue, then?
I'm just saying, I understand the process, but would love to hear an example when you say what kind of a social factor would actually we need to be determined using a Bayesian.
Okay. Got it. What kind of okay. I hope the screen is visible.
You
We
may have to
have
speak to it rather than, because I can
okay.
make out the colors very well, but the fonts are pretty small.
Okay, understood. So basically, we were trying to look at, how try to model how one person would interact with the other person in the same team, and that would, give a boost in the performance. So we get these metrics via standardized personality tests, but the interactions is not defined. So what we thought of doing was we sort of create clusters and pick people from the same cluster so that it's very easy for them to communicate with each other. That's one scenario. And, basically the other scenario would be your social cohesion and attraction. So cohesion is defined as, how likely are you to carry the team in case something goes wrong, in very simple terms. That is very difficult to model via these metrics. So we were trying to get the personality metrics and cluster them so that this can be modeled, if I'm making sense.
You're making sense, but you're moving more towards a different approach to it rather than a Bayesian. So if I understand it well, let me say this. So let's say interpersonal skills, whether it is communication or the others, is one factor, as you told, right?
Yeah.
And similarly, cohesion in a group, maybe the other skill. But where I got confused was when you said you have clustered it. So that clustering will only give you whether this person can be cohesive or not,
Okay,
or a
so
score of that cohesion.
yeah. So
is that what you're using in the Bayesian to decide something?
right. So the reason why I mentioned the clustering is if you see the Bayesian network, right? So you feed in the data at once, and on the output, you're getting the team members. So the output actually depends on the other members that are being selected by the model. And this sort of requires a relative data point. And that is why we were trying to define that using clusters.
No, that's fine. My
Yeah.
question is not why you're using clusters. My
Mhm.
question is, if somebody is clustered in a cohesive group,
Okay.
right, is that the input to the Bayesian to decide?
Yes, that is decided by the Bayesian whether they are actually cohesive or not, to say the least.
Okay, I got confused now.
Yeah, but we
First
didn't
you
get the
said,
yeah. So Vishal, I think uh, 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 we'll try to I think be more crisp, right? I mean, so one thing is clear that from your presentation that the first uh, what you're doing is you're matching the candidate to a role using a Bayesian, which I think is pretty clear, and it does the right use of a Bayesian network where I'm trying to find whether this person is suitable for that particular role or not, right?
Yes,
I think the second column, when we talk about or when we thought about this task formation, that anyway I've done that, right? I mean, so I already have, let's say 10 suitable developers for my. But now the second problem is that how do I form a team so that the personalities are balanced, right? Because everybody has a different personality trait, right? Or there
Exactly.
are some complementary skills, right? So
Exactly.
the second problem is how do I build that model which exactly do this matching so that I pick the team which is overall balanced, right? Or maybe at the team level I have the right skills, the right technical skills, soft
Understood.
skills, right? That's the
Yeah.
second problem. And the third problem is the trade-off, right? I mean, like Vishal said, in the team, I can, I mean, that's a typical problem we face in the corporate, that I can pick the best team, but it may not be very cost effective, right? Because so I need to trade off between, the skills and the cost, right?
Exactly.
And that may
So
be problem of a trade-off algorithm, right? I mean, may not be solved through Bayesian network, but overall we create this kind of a decisioning system, which includes, maybe a few other algorithms to come up with it, right? So at least I'm
exactly.
not getting the clarity on the team formation part.
So the team formation, we have considered certain parameters. We have defined parameters for that. And the second point is we have defined the utility in such a way that it is cost optimized. So if you remember, I told you about, giving certain weightage to performance and certain weightage to cohesivity and so on, right? So that utility can actually be modeled for every single role. And you would get the cost benefit from that angle.
Okay, so in the interest of the time, I mean, on a concept level, we agree.
Yes.
And we understand what you're saying. We are on the same page. But getting into the implementation details of the decision model, I mean, possibly it is not clear. Maybe, because maybe you need to provide maybe a few more details into it, or maybe the right examples, which are missing. But overall, I think we got it. So thanks.
Okay. Thank you.
Okay, thank you, team. We'll move on to the last presentation before we take a short break. So, team 17, are you ready to present?
Yes, Ananya, we are ready.
Okay, sure. So you can start.
Can you just
So-
give me a quick audio check if my audio video is all right?
Yeah, it's all right. And after the break, we'll have team 47. So we are just switching it because they were here already.
Sure.
So you can start your presentation.
Yes.
Checking my audio as well. Am I audible?
You're audible.
Okay. Yeah. So hello everyone. This is team 17 with our solution Crazy Wall. Crazy Wall is the bulletin board used by investigators to visualize and connect case details. You must have seen one of these in the detective movies where the protagonist gets an epiphany looking at the crazy wall and the case gets solved. Just this time, there will be no epiphanies, but only data-driven story building. So we will first establish the need to automate, understand some critical aspect of law enforcement, consider a sample case and parameterize it. We will then dive into the decision model, showcase the knowledge graph built by us. Subsequently, we will explore how impactful the implementation of the crazy wall could be, and then state the domain experts' input.
Yeah. So I think, Rohin, sorry, so both me and Vishal, we come from this domain. So we have worked with a lot of intelligence agencies in India, right? All the 2-letter, 3-letter agencies, right, which we have. So what you can, and we have a lot of questions to you. I think what you can do is maybe fast forward, the presentation quickly. Don't give the background and justification and all those things. Maybe come to the solution, and then we'll have more question answers. Okay.
Wonderful. I think that works for us. I'll just very briefly state the highlighters of each slides that we prepared, and then do what you're saying, sir. So I think it's highly important because a 10% annual increase in crime rate is encountered, and 2.5 lakhs of annual crime cases are left, and more than 24% of our workforce is engaged for more than 16 hours. That's a lot. A brief background would be that evidences are the building blocks. The data of the fact is bucketed into means, motive, and opportunity. So multiple pieces of evidences paint a story around a suspect using possible means, motives, and opportunity. And the story is evaluated basis on the probative value of the evidence, proving or disproving the theory. And the probative value is the extent to which the evidence could rationally establish the truth of a fact. The major agencies are, of course, CBI, ED, NIA, NCB, CISF, the state police.
Now that we have established everything about the background, we decided to use our expertise to solve a case. So it basically goes like, there's been a murder, and Dr. Elizabeth Carter, who's a highly renowned art historian, was found dead in her office with a gunshot wound in her head. At that body, 4 suspects, a crime scene full of evidence, and a growing itch to catch the perpetrator. But before we dive into our solution and the technicalities of the case, we need to get acquainted with the suspects. So there's Amanda, the sly ex-intern, Jack, who's the guard at the museum who's drowning in debt. There's Robert, the notorious art collector who was being investigated by Carter. And then there's finally Peter, the rival art historian who was riddled with jealousy. So it's been previously settled that pieces of evidence form the backbone of any case. Now, out of the entirety of the information that's been given to us about an issue, we look to identify the relevant bits and pieces and present them in the form of parameters. We have curated a generalized list by following a comprehensive process. It comprised of an all-encompassing task of going through case logs, talking at length with domain experts, exploring modus operandi parameters, and extensively reading the relevant literature. For the sample case mentioned, the mapping of relevant parameters for a knowledge model shown here. Now it's time to piece together the details and make a story out of all we have. And we do that using an intricate process. So first, in the model architecture, it begins with pre-processing of data collected from the crime scene, the lodged FIR, and the investigator's overview of witness statements. So the case log handed over to us is formed using the clean data. What follows is a list of suspects to be considered for further investigation. Now on to the data segregation block. Here, the relevant features of suspects are fed into 3 data sets, which later come in handy in determining the potential modus operandi for each suspect. Each of these 3 CSVs is used as an input to a random forest decision model, which builds a story around each suspect by classifying the motive, means, and opportunity. There's an inbuilt query mechanism which helps the police officer. We get into the nitty-gritty of the model with the help of motive CSV. It contains all those aspects about a suspect that could possibly lead us to their motive. Motive is essential in determining the culpability because it tells us what could have driven a person to commit a crime. The decision tree uses distinguishing features at every step to try and separate suspects, leading us to their potential motive. So for Jack, it was questions regarding his professional relationship and financial stressors. And a similar process is undertaken for means and opportunity as well. As our output, we paint a picture by tabulating these. The weights mentioned here are manually assigned by the investigator using their expertise, the probative value, and the feature importance fed by the model. Using this table, we calculate the culpability index for Jack, which is just a linear summation of the 3 weight values. Here, the values are representative, and alpha, beta, gamma are just variable values that depend on the investigator. Now, with all the data at our expense, we form our very own crazy ball. This knowledge graph enlists all evidences, nodes, and links, and the reasoning is shown by the arrow conditions and directions. It expertly exposes all the correlated parameters. The query is used for filtering out facts and revelation based on entered logical conditions. We have shown the entire connection web for Jack, so the investigator may analyze one suspect at a time. Jack is the intersection of all four conditional queries mentioned. Therefore, it becomes easy for the investigator to filter him out and derive implicating evidence.
So what impact do we expect Crazy Wall to create? The time taken in the investigative analysis of a case is expected to reduce by a remarkable 50%. The crime clearance rate, which is the annual number of cases solved versus registered, is expected to increase from 44% to 78%. There is also a high scope for repeatability, standardization, and enhanced interpretation.
We are extremely fortunate to have gotten through to the highest authorities like Director of NCRB and CBI, from giving us an insight into the vast and enigmatic world of crime investigation to validating our solution. We have our domain experts to thank. Their inputs were instrumental in helping us understand where our approach comes into the picture.
Okay, thank you. I think very good presentation. So I have a few questions. Okay, so one thing is clear that we are building the knowledge graph or doing a link analysis so that we can link all the facts and evidence together, right? And which is a pretty well established thing in intelligence and police organizations, and they use multiple tools to do it. And second is I can run the query on the graph. I mean, trying to find the links or, like you said, conditional queries. So that part is clear, right? And like I said, I mean, I've been working in this area for long, and this is something like is very visual, and clearly the investigator or the analyst who is looking into the data is able to draw the conclusion, right? So my question is actually to automate that conclusion, right? In terms of finding a suspect or coming up with the probability of, that person, like you explained. But I'm not exactly clear that how, I mean, one I got is the decision tree approach, right? Where we build a decision tree and possibly maybe I'm assuming or telling on your behalf that some of the queries is actually answering to the nodes of these decision tree to come up with a decision, right? But how does Bayesian network actually fit into it? Maybe can you explain that? How can I use the Bayesian network for the decision making or actually identifying a suspect?
So we do not have a Bayesian network for our knowledge graph. There are multiple types of knowledge graph. So the kind of end classification that we're doing is not probabilistic based. It is discrete because in a criminal investigation, there usually isn't a probability to what could be the motive. I mean, we have bucketed similar types of motive into one type discretely through the decision model. So we do not enforce a Bayesian type of network. We therefore go for a discrete model, which is explained through the knowledge graph later. Does that answer the question?
No, that's answer the question. And that's actually in line with my understanding of when I was going through your report. Although I think, or I have some ideas in terms of how we can apply Bayesian network on top of the knowledge graph to come up with. I mean, the biggest problem these guys actually face is that they have a lot of data. Right, first thing is to convert that data into a knowledge graph, which you have demonstrated. The second thing is that they're very short of analysts who actually can go through this data and come up with their conclusions, right? I mean, so normally the way that it happens is the senior officer, like all these IPS officers which you have listed down, right? I mean, possibly they ask some queries, then the analyst will go and then get into the data and fetch the and these senior officers, they actually do this decisioning in their mind, right? I mean, they have the knowledge, right? And the idea was to convert that knowledge into a decision model, right? So that we can even automate that process. But I know is again like a bit more complex. One need to really get into the next level of depth. But I'm done, right? I mean, I got the idea, or at least what you are proposing. Vishal, you have any questions?
Many, but I'll limit it. The time limits us. I think team, good work. As soon as you use the word motive, I could know that you talk to some police officers who actually know how to go about it. So that motive word with the means or evidence is a very typical approach. Um, so good, but I'll tell you a different take on it, and especially expanding on how Anuj was saying. While it is understandable, as soon as I saw your graph, I could make out you're taking a Neo4j kind of a thing, wherein you have the knowledge put in. And this is where most of the agencies you talk to, their approach is to find it in a way just that instead of individual queries, they're running a linked query today. And you're trying to find linked factors. That's what graph does to you. But the whole idea is that they suffer from an attention problem. So what that means is you have so much of data that comes into the system through the unstructured and structured. Um, which are the ones that you want to seek these queries on is the most important thing. You cannot go after 10,000 people, and every state police has its issues, and it gets rolls up into the central agencies and other things. The Bayesian network approach, as Anuj was saying, has to come out. It's a very knowledge graph driven approach, which is understandable. But is there a way I can find out that a knowledge graph will have a very fixed set of nodes to say if there was motive and there was a gun involved, well, this is the guy we want to go after. But what if there was a different way wherein you're saying if these are the events that are happening, right? And you have a Bayesian network around event and its correlation to other entities, then you are able to actually say that instead of spending your time, putting your attention to all of these. By the way, the agencies always have a list of people that they want to monitor. For them, they are just populating the knowledge graph with more and more evidence. So that's the approach that I see here. I'm just saying, is there an alternative wherein instead of you having to skim everything, the system actually decides or give you decisions? Or these seems to be anomalies. Now, based on these anomalies, let's fit them into a knowledge graph and then find out whether these uh, uh, is there a motive that we can find behind these anomalies? Did
So
I make
yes,
sense?
sir.
Right.
Yeah, so I understand with your idea and approach. Here is where the concept of explainable AI steps in. So the investigators can actually see where the anomaly actually broke out in the model and then take accordingly the decisions. So by this, we can also handle the biases and the historical disparities by this way. And regarding your previous query, like regarding the layering of our knowledge graph, we can actually assign weights to the nodes linked to various other nodes as well. So I can like actually determine the priority order of by determining the weights to which a load is linked.
Just to add to Heryl's comment, I think how much a node is interconnected will be one of the factors that will be considered to prioritize that node. There can be other factors as well, as you rightly mentioned.
Yeah.
I mean, yeah, the way this has to be looked in, and this is impressive, is that you figured out that how would you link the information so that you run the least number of queries to be able to get to the list you want to go after, right? Or investigate into, or actually find out whether this has all the evidences needed or not. The problem that is faced today, which is where the decision making comes in, is one to see which are the events we want to put our attention on and which are the entities involved those events, and then it comes to the level whether can we prove there's a motive and means to do it and all that, right?
Yeah. So I think
Look at it reverse way. Look
Yeah.
at it reverse way.
Yeah, I think Vishal, in the interest of the time, I think just last feedback, right, is exactly what Vishal is saying. Currently, the approach is actually bottoms up. We, get all the data, then we put all the data into a graph, do the link analysis, then, answer some queries, and then take a decision. Can we reverse it, right? I mean, can we actually create decisioning model around entities and events, and based upon that, actually get the queries and identifying suspects, right? Anyway, it's a longer discussion. We can have maybe more discussion offline, but right now I think we are good to go. Thanks.
Okay, thank you, team. We'll take a short break now. We'll resume after around 10 to 15 minutes. So, team 47, we'll begin with you when we come back.
Uh, if it's not too late, and if I could just add that there was, we talked to the domain expert, and currently in the scenario, there was something like crime matching, and on the basis of modus operandi, there's been like stuff going on where you can, there's like big data sets which have modus operandi parameters, and crimes have been matched and mapped on the basis of that.
So I do get it's a very brute force kind of an approach, but it's in the place, so we are kind of constructing on top of it.
Yeah, exactly. I mean, you use the right word. I mean, currently the approach is more brute force. It depends upon the intelligence of the officer, right? I mean, to ask the right question, right, to get into that kind of query. Think about it. I mean, how can we automate that piece, right? I mean, which that officer is doing.
Because from the perception of the officer, like we talked to the director of NCRB, they were very, very focused on like the investigators constant putting in the model their own feedback. Even we talked about the historical skew of data, the gender biases. So they talked that keep all the biases, let the data speak for itself, and we'll ourselves model it.
Actually, the Indian police or intelligence agencies, they are so much overstressed and overloaded with all the cases and the data. They don't have they're not thinking in terms of what we are talking about, right? I mean, they are still struggling with data. It still takes weeks for them to actually get any insights from the data. So currently, what all of them are working on is actually the digitization of the data, then creating this crazy wall, or doing this link analysis visualization, and we are addressing the horizon 2 problem, right? I mean, the which I'm sure nobody is thinking that way. But anyway, it's a good.
They were
good
super
work.
enthusiastic and open to our ideas. They even asked us to come down to the NCRB office and explain it to their leadership so that they can get into their vision.
Yeah, sure. I think let's discuss offline, because we also have a lot of ideas in this area, and maybe we can take some of these to them and see, are they interested in doing some kind of a pilot. Yeah. Okay.
Thank you.
Thank you.
Good work. Thank you.
In the meanwhile, Vaibhav, can you test for the buzzer sound?
Yeah, just a minute.
Okay, it is audible. Just play it once when you
Okay.
play the buzzer. Okay, we'll begin in a while.
Is it possible to continue? I mean, because we want to finish it by 1. So
Team 47, please be ready. We'll be starting in 2 to 3 minutes. Team 47, you can start your screen sharing, please. Yeah.
Is it visible?
Yeah, it's visible. You're audible. Vaibhav, please start the timekeeping as soon as they start. You can begin.
So good morning, everyone. I am Ankita from Team 47, and our topic is crop recommendation system. So we envision a world where most of the processes involved in agriculture are largely automated, starting from the decision-making process all the way to the harvesting and the selling processes involved. So the first step that we will take towards it is crop selection. So in a country like India, where we are faced with various unpredictable weather patterns, changing quality of soils, danger of pests and diseases, selecting the optimal crop for a location is a very difficult task. And improper crop selection can lead to poor harvest, lower returns for the farmers, making their lives difficult. So, especially in a country like India, where agriculture is the largest livelihood provider, employing over 60% of the country's population and having an 18% share of the GDP. Add to that the fact that India has 20 agriclimatic regions and has all the 15 major climates. It's very it provides us a large opportunity to deal with diverse types of crops and diverse locations. Currently, the agriculture and allied sectors have a market size of 271.9 billion US dollars, and the government is largely pushing for digital agriculture mission, which is trying to add technology and digitalization to agriculture. It's also one of the approaches include the data-driven decision making and market intelligence to increase farmer incomes. And agri-tech startups have raised over 636 million US dollars in 2021, which is from 155 million dollars in 2020. So the possibilities in this field are endless. So this is where our solution comes in. We'll be taking into account various factors which may not be very evident to the farmer himself, such as the weather patterns, soil types, the various costs and the revenues associated with each type of crop, so as to provide an optimal choice of crop for their location and to minimize their costs and maximize their profits. Moving on to the next slide. So our solution will employ a Bayesian decision-making system in the backend, which will take into account more than 100 parameters, which will potentially affect the yield of the crop and finally affecting the profits associated with it. We have tried to replicate all the dynamics of the real-world situation and take into account all the different uncertainties which are associated with the decision-making process. And we have considered the input parameters as well as the correlations among these parameters. So initially, we'll be focusing on different farmers' unions, as it would be difficult to tap every individual farmers. And we can also look for medium or large scale farmers as our customers. And dealing with the sarpanch of the Panchayati Raj system is another option. So once we have established a strong foothold in this domain, we can move on to the we can move on and approach the government agencies and extend this solution to a nationwide level. And after having acquired a large data set, it would enable the government to predict the demand and supply for different crops throughout the nation. And it can also help the government implement a grievance resolution system to identify critical zones and pain points. Now, my teammate Ashutosh will take you to the various parameters.
So for the model, we have divided the parameters broadly into three categories. The ecological category, which takes into account the environmental factors, the economical category, which takes into account the costs involved, the feasibility, And the fourth one, which is the legal and the cropping pattern, which can be incorporated later on when we have enough data about it. So first of all, the ecological parameters, this takes into account the weather in the region, the soil type that is there, because every crop has different requirements. So the water resources that are available, the pests and diseases that may affect particular types of crops, the location of the farmers, the climate in the region, and the waste generated by particular crops. Then the economic parameters we divided into two broad categories again, the cost and the revenue. Costs include the cost of seeds, cost of harvesting, cost of purchasing the pesticides and fertilizers, the labor costs, storage costs, and the costs of running the equipments. And for the revenue part, we have the MSP of the crop that is there, the market price availability for the crop, the yield per hectare for the seeds that are being used, and government incentives for any particular crop, since all crops have different types of incentives from the government. Then for the feasibility parameters, this takes into account, first of all, the resources that are available with the farmer, such as the land size, the machines available, the tools, labor, livestock, and if there are any post-processing machines for any particular type of crop. Also, because investment is needed at the beginning of every cropping season, ease of credit is also important. So ease of credit again further depends on factors such as the background, the age, education, etc., and the experience of the farmer. And lastly, we have the information available to the farmers, because while growing sensitive crops, it is important that there is access to accurate information. So this takes into account the if the farmer has access to internet or access to KVKs and the experience the farmer has with particular crops. So lastly, to conclude, I think this project can help improve the efficiency of the agriculture sector by a huge amount, and it can also help improve the lives of the farmers. And I think this is a good example of how we can employ our existing technology in sectors such as agriculture. So yes, this is how we plan to harvest the future with this technology. Thank you.
Thanks. Vishal, any questions?
Yeah, the only question I have is, I'm not sure, or maybe it may be interesting for people on the team to actually look at how an approach of this type, I'm not saying Bayesian or a decision-making approach where we want to tell farmers that what will be the best way to go about it based on all these factors. Would that drive us towards a future wherein the model may just say just everybody grow basmati rice, and how does it take other factors into these things that eventually you want people to have, while it should maximize the return for them, it should also be taking care that everybody cannot be growing the same thing, given that you may be falling in the same area. So I'll give you a background of why I'm saying that. If you ever go through the fields in California, right? I'm giving that example because the farms there are so big, right? We don't have that large land holdings here, but that consolidation happened there, wherein everybody you drive there and you see cornfields, and the sugar syrup there is totally corn driven, not the way we get the cane sugar here, right? And they deploy a lot of IoT and other stuff, but at the end of the day, it is all being driven towards a profitability approach, wherein trying to bring uniformity to how you do it, and then uniformity sometimes leads to you just focusing too much on a certain type of crop. Are we trying to address that? Uh, would the solution address that kind of thing also? I do understand the land holding pattern may be different to the example I gave. The land holding pattern here is way smaller, but you're not telling at a micro. Are you telling at a micro level that given a village, most times most farmers actually will be growing the same thing?
Okay, so that's why in one of the points we have mentioned that instead of tapping individual farmers, we will be looking towards, let's say, the farmers unions. So our model will not just be outputting one type of crop. It would be offering multiple types of crops. Like let's say one is the most profitable one, then there are like two, three other ones. So if we take all that into account, the farmers union can then diversify the distribution of the crops to the farmers, and then I think there's some type of pooling of profits that goes on in unions, so that can be taken into account. And moreover, the eventual solution is to offer this to the government itself. So once it's like the model has generated a sufficient amount of data, we can offer it to the government, and then they can use it to change the MSP or to provide incentives to different farmers to ensure that we have a sufficient demand and supply for each type of crop, and to ensure that not everyone is uh, 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 planting the same type of crop in a certain location.
Yeah, I agree. But that brings to the last question I have on this, which is like, is this a good planning tool or a decision tool?
So the starting of this is a decision-making tool, but as we mentioned in the future prospects, it can be integrated to form an entire planning tool as well. So since we'll be taking all these ecological, feasibility and cost parameters into account, it can also be used to generate proper planning in the entire process of agriculture. Like let's say offering the amount of fertilizers or the optimum amount of water that the plants might require. So that's something that can be taken into account in the future.
Got it. Thank you.
Actually, a very good answer. In fact, all the decisioning models actually can be input to your planning, right? So, so when you convert that into, the complete data set for the whole state, right? You actually have all the inputs required. We exactly know that if all the farmers are growing these type of crops, so what fertilizer will be required, what irrigation is required. So I think, yeah. So no more questions. I think I agree to whatever I think Vishal and asked and you answered. One is the crop selection. The second problem is actually a macro level planning, which possibly the state government or the center can do, so that you plan out the things, keeping in view the supply chain and all the other parameters associated, including the planning. Yeah. Good. Thank you.
Thank you.
Okay, thank you guys.
Thank you, sir.
We'll start with the next team, that is team 29. Team 29, can you begin your screen sharing?
Yes, is my voice clear?
Yeah, your voice is clear.
Okay, so I'll be starting my team screen sharing.
Yeah, and there'll be two buzzers which will be sounded for you, one at the 3.5 minute mark and one at the 6 minute mark.
Okay, sure. Is my screen visible?
Yeah, it is visible. You may start.
Okay, so hello everyone. This team 29. So we had a task for sports analytics. So basically, we were focusing more on the football analysis part. So this is what the decisions that we had to make. So first, we have to actually automate the task of a coach, a selector or manager who is mainly assigned for selecting the players for the coming fixture. So we'll be actually making ratings for the players, or we'll be selecting the players who are fit for the upcoming fixture for the upcoming match, which will be based on their physical statistics that could be the latest possible, and also on the past performances of the players in the past matches. So we'll be also taking in care the injuries and how is the fitness and all. So here's our solution. So firstly, we'll be starting by what parameters we are using for solution. These are the physical statistics, mainly the body fat, flexibility, strength and power, agility, repeat sprints, and aerobic fitness. These are the basic physical statistics that are used also in most of the teams for the testing. And finally, the past game statistics. So they have the goals per game, assists per game, goals saved per game, reaction time, passing accuracy, and years of experience. As you can see that most of these will be very numeric. So I don't think there is much explanation required, but for the physical statistics, we'll be having the following tests performed on the players. So for the body fat, these are the following tests: the skin fold test, the measuring body weight, waist girth test, and and then for the strength and power, we can have the vertical jump test to test how much is the reach. Mainly, this will be more required for the goalkeepers and the defenders. The 1 RM bench press test, 1 RM squat test, repetition max deadlift test, lat pull down 1 rep max test, and power clean max lift test. And the repeat and the sprint test, which are very much required because the forwards need to be fast so that they can outrun the defenders. And most of the players, if they have a high pace, it's a big advantage for the whole team. So there is the 100 meter, 60 meter, or 30 meter sprint test, whatever is required by the position where the player will be playing. The sprint fatigue test, so it could be seen that how much a player can sprint without being exhausted, and the LIST test. Then there is for the flexibility, as you can see that in modern day football, a lot of aerobic moves are also played, and the goalkeeper needs it very much too. So the flexibility test, there is the sit and reach flexibility test, sober test, the stand and reach test, and the agility, which is required mostly by the midfielders and the forwards, so that they can quickly change directions, do feints and all, which is very much important for them. So there is 505 agility test, FIFA change of direction test, Blossom test, and Arrowhead agility drill test, and the aerobic fitness test. It is mainly to test the exhaustion, the shuttle run test, and yo-yo intermediate test. And we'll be using a decision tree model, which is basically a form of supervised learning algorithm, which does both classification and regression tasks. So we can have a hierarchical structure, and we'll be deciding on how these parameters will be used, starting with the basic test. So my friend Shriyansh will be now starting with the decision trees.
Hi everyone. So we know that a Bayesian model is based on a probability distribution model. So what we have done in this particular problem is that we have used a decision tree to rate the players according to different positions. And then accordingly, using the probability distribution model, we'll decide which position is best suited for them. So this model classifies the player into 4 major groups, out of which, except the goalkeeper one, all other groups have several subgroups in them. These 4 groups are goalkeeper, striker, midfielder, and a defender. After a long research on the domain knowledge as well as constant talks with our college football coach, we have managed to gather the most important parameters which are required to classify the players. Firstly, we'll have to decide which all players from the squad will be in the playing team. So for this, we have found out that body weight is the most important parameter. And if the body weight is less than 130 units, then we'll pass the player into further units of testing, which are as mentioned in our slides, which are in the decreasing order of importance. They are flexibility, strength and power, sprint, and ultimately the player would be selected into the team. Now, let us talk about the decisions for the goalkeeper. Definitely, height is the most important parameter for a goalkeeper because he has to save goals throughout the goal area. So after the height, the parameters in the decreasing importance are mental test, diving reach, and then finally the number of goals per game. Mental test is considered as a quite important parameter because whenever there is a penalty or everything, the mental stability of the goalkeeper plays a quite important role. Next comes the forward position. In the forward position, sprint time is considered to be the most important parameter, after which
Other parameters are marathon run, mental clearance, jump reach, and goals or assist per game. And ultimately, the last parameter is of experience. If the person is right foot dominant, we'll consider him as a right winger. If it is balanced, we'll consider as a center forward. And if the left foot dominant, then we'll consider the player as a left winger. Then the position comes of a defender. For defender also, the most important parameter is mental test, followed by reaction time, then number of interceptions, then passing accuracy, and ultimately the number of goals. If the person is right foot dominant and the sprint time is less than 15 seconds, we'll consider the person as right back. If it is balanced, then center back. And counterpart, if the person is left foot dominant and the sprint time is less than 15 seconds, then it would be a left back player. And ultimately, for the midfielder, we have to check the exhaust time of the player. If it is greater than 20 minutes, we'll consider as fast. And the other parameters are sprint time, number of assists, passing accuracy, number of interceptions, and ultimately the number of goals conceded per game. And talking about an overview, we
Time's
have
up.
the base. Okay, sir. Please, if there are any questions, please go ahead with that.
Yeah, okay. Yeah, one or two questions. I mean, one is we could have actually converted these decision trees into Bayesian models because, for example, all these parameters which you are taking, right? For example, mental test, right? So again, it's not a discrete. I mean, it's like you'll have multiple, values, right? I mean, for example, the score of a mental test can range from 1 to 10. Now 4 could be minimum, right? If it's below 4, you will reject it. But what happens if, for example, one person has a mental score of, let's say, 10, another has an 8, then second has, the flexibility score is, maybe higher. So again, you can actually, along with eligibility, so recently actually do a eligibility check, but you could have actually built a Bayesian network which will score the player, right? So that you know that if there are 5 people who are eligible for the same, uh, uh, position, which one has a higher score? Isn't it?
Yes, sir. Completely understood the question. Firstly, as mentioned in the while presentation, we are using the decision tree just to rate the players according to different positions. And then accordingly, we'll run the probability distribution network to decide which player will suit the best position. Now, coming to the question regarding the mental test, suppose 4 is the last value of the mental test, then the player rated 4 in whichever field, like the goalkeeper requires the best mental fitness. Then in the goalkeeper position, the rating of the player would decrease. But for a defender, the mental position is not that much required. So for the defender position, the rating of the player would be increased a bit. And for this, for all the players
Okay.
who are selected from the squad.
So what I understand is, okay. So what you're saying is that you have a model which will actually score a person for a particular position, right?
Yes, sir. They'll score all the persons for all the position. Then we'll choose the best scores in those particular positions.
Yeah. Okay. Okay. Got it. Okay. So no more questions from my side, Vishal.
No, I'm good.
Okay. Thanks.
Okay, thank you very much.
Guys, we'll start with the next team, team 45. Team 45, are you ready?
Yeah.
Sure. So you can start your screen sharing. 2 buzzers will be given to you, one at the 3.5-minute mark and one at the 6.5-minute mark. Sorry.
Okay, is my screen visible?
Yeah, your screen is visible.
Okay. Let's start. Good afternoon, everyone. We are Team 45, and we are here to present our take on making efficient real estate investment decisions. So why did we think real estate is a good use case for the cognitive garage tool? Let's try to understand that. Despite its reputation as a relatively safe investment option, real estate investments actually have a poor track record in generating returns. Over 95% of the rental investments fail to yield expected returns within the given time frame. and 58% have abandoned their investments due to lack of returns. Real estate decision making in India often relies on intuition and conventional data, causing difficulty even for the seasoned professionals. Additionally, current decision models are rarely used in the Indian market. That brings us to the three major pain points: manual effort, human bias, and multitude of parameters. And so we finalize the following problem statement. The complex technical knowledge required for utilizing current decision models poses challenges for both the general public and the real estate firms. The numerous intricate parameters involved just add to the difficulty, leading to manual decision making errors, which justifies the need for an easy to use decision making tool. Our proposed model automates real estate investment decisions by evaluating around 300 decision parameters to compare ROI and risk across potential investments. Now let's try to understand the use of it. Real estate investors turn to brokers or consultants to buy residential or commercial plots, who then use our model to find properties based on the client's preferences. The model calculates scores for attributes and ranks options, allowing the consultant to recommend the ideal property on a quantified basis.
So now, as we have having a bird's eye view of the model, so now let's look at from a layered perspective. An investment decision can be generally broadly classified into six major broad parameters as based on a domain name. Each of these parameters are dependent on several score values, which are calculated on certain sub-parameters. First, now it's very complex. So let's simplify it and let's look at them one by one. So let's start with the growth and development. Taking into account the scope of development of a region is one of the major investment decisions while calculating and scoring out any investment decision that's in a prolonged time of investment often affects cash of the investor. A model takes into the consideration of the various parameters like communication, connectivity, environmental, and proposed economic development factors to get a quantified score out of the same. So the correlation of the parameters we have tried to show in the next slide. So I'll just brief them about the slides that notes that we have made. The last notes are the leaf notes, the scores of which will be affecting the notes above them, and the cumulative scores of all of the notes will be giving out the score, which will then be used to get the property score, which will be bring ahead. So
Cannot hear you guys.
Hello, is he audible?
You're audible, yeah.
Okay, just a second. He'll rejoin. Just a second. Hello.
Yeah.
Can we restart or we should continue from the same?
You can continue. The timer will continue from here, then.
Headphones. Okay, just a second. Okay. One second. Should I restart from here? Am I not able to hear?
Yeah, you can start from here.
Okay, cool. So we will be covering the risk parameters here. So the risk and the investment is one of the major factors by considering any risk decision that's gonna make by the investor. So often the risk that we consider is not even quantified by the investors and often not taken into consideration by the investors, which even results in a prolonged time of duration of the investment and often results in affects the cash flow of the investor. So our model takes into consideration of the various sub risks that we and quantifies it and gives a score for the risk parameter, which in turn affects the property score that's gonna be made from the final decision output.
Okay. So next slide, please. So this is the model that we have proposed and the interconnection that we have made for the risk parameter. So now we will be moving on the financial parameters. As we were conducting user research and from the domain experts and the real estate investors, we found a major thing that they were not able to connect to the financial goals and also the current global market trends. So what we thought, we were listed out certain parameters we will be ranking out them, and the values of which will be calculated from the data that we had, and which will be then to make effective financial investment decisions that can be used to calculate the property score, and based on the user inputs, it can be used to make effective investment decisions. So here's the notes that we have proposed for the financial investment. So now comes the legal parameters. As we all know, 2/3 of the Indian cases pending in the Indian judicial system are of real estate, which clearly justifies the need for proper consideration of the legal parameters and their correlation and the parameters, and also analysis of the previous data, previous legal disputes, and the correlation with the existing investment decisions, which can affect the future investment decisions of ours. So this is also a major parameter that we should be considering, and it also has an effect of the major investment decisions. And here's the proposed model that we have suggested for the investment. Now comes the investment parameters. So as my father is a real estate investor, and I wanted to, and regarding the PS, I had a talk with him, and I asked what type of investment do we generally make. The answer blew up my mind, because exhaustive list of the parameters and the correlation is generally he's not able to take into account manually or intuitively, and it's even difficult for the real estate consultant. And hence, considering all the parameters related to the residential, plotting, commercial also becomes a major factor while deciding any real estate investment decision. And here's the notes that we have made for the same. Now comes the seller or brand parameters. So whenever we make an investment decision, the most of the investors, what they feel is like they are not able to trust the seller, and they are not able to quantify it. And often the real estate consultant, when they approach a new developer, they are also not able to make a trust out of it. So what we devised was certain parameters for this: credibility, market expertise, and financial stability, which in turn, giving scores out of them, can be used to quantify the stability of a developer or a seller, and also make effective investment decisions. So here are the proposed notes that we have suggested. So finally, we have scored out all the broad parameters. Now it's our time to get to the three main broad parameters, which are asked by any real estate consultant to an investor when it comes to him for making any investment decision. These are return on investment, overall risk factor, and confidence level. So return on investment is basically a layman general term for any investment, which includes like what return on investment am I gonna get it from the 2-year investment or 3-year investment, and it is calculated on the scores of the various subparameters as discussed before. And overall risk factor is all the risks associated, clubbing all the risk parameters such as market risk. So confidence level is all the same.
Yeah, this is the modular architecture that we are going to follow. And to summarize, our decision model solves the challenge of real estate investments by maximizing maximizing ROI and minimizing the risk. Thank you.
Vishal, you want to ask? Vishal.
Sorry, speaking on mute. The typical problem we face these days. I think we should have a decision tree to mute and unmute.
Sure. Because of the connectivity issues, I guess we should be having a decision tree, like how should we getting properly connected to the net for the presentation.
Yeah, pretty impressive in the way you have captured a whole lot of parameters that are out there.
Yes.
Right. I just want to hear some views around. It's pretty wide coverage as far as to make a decision. Would we take all the factors into consideration? I want to hear out, or I didn't hear out too much on the automation aspect of it. So when you say the audience, whether it is the seller or the agent and others, what is it automating for them?
So sir, like if we consider the factors, as we all can see from the model itself, there are a lot of factors that need to be considered before making an investment decision. But it's not currently taken into account either by the investors or the seller itself, or by the real estate consultant also, because it generally is not possible to manually relate all of them. So what a model suggests is that it can automate the correlation between them, and if we input the suitable parameters, and we can predict the investment decisions. Currently, when we talk to the real estate consultant, they were like, when I talk to three real estate consultants from the same location, for suppose any other USA suppose location, they suggested me you should invest here because I am telling this. The other suggested you should invest in B because I suggested this. The third told to invest in C. But actually, what is the best for me? I need a quantified score for the same, and it's currently not manually possible to relate all the parameters. So that's the process of automation that we can solve.
No. I think the question also is, I think the problem is very clear, and the agent will tell you to invest in a property where he is getting more commission, nothing to do with the interest of the buyer. But the issue is all these 100 parameters which you have mentioned. Is this information available? Can we automatically get that? Because we can build a model, right?
Yes.
But the question is for example, let's say you mentioned about legal title, right?
Yes.
Yeah.
Now, how do I find out whether what is the status of that legal title? So, is that information, all the information which you mentioned, is it available in public domain or with government agencies? Is it easy to automate? So that I just input a property name and I get all this information.
Got it.
Yeah. Actually, we have words like there are many government agencies. Let's suppose it's going to be zonal title. So we have municipal communities, or you have codes like where these data are already there. So it's like we can have a correlation with them, or we can have a association with them, and we can get the data from them. So that's how we can get the data, and from those sources. And like there are a lot of sources for every parameter. Like for crime, you can get it from the police station source.
So like adding on to that, like in the report, in the appendix part, we try to source out the data that we have taken for the parameters as much as possible. So for some of the parameters, it's obvious we won't be getting data in easily available. So that we will be taking the domain experts input, and we will be running out a survey. From the survey part, we can get most of the data which is not easily available with any of the agencies, or which is very critical to encode or decode the data so far. So the list of the search parameters won't be much greater than the parameters which is data of which is easily available. So
Got it. Second is, have you considered the preferences of the buyer, right? Because the buyer, like you said, he's buying a property, either plot or a commercial or a house. Again, there are multiple factors. Age of the person, the risk which he's willing to take, right? Is he buying it for staying there, or more for investment purpose? So there are a lot of preferences of the buyer also, right? Because and end of the day, I need to do a match. The model should be able to, one is the risk rating of the property. The second model should be able to actually recommend a property based upon my preferences, right?
Exactly.
Have you considered that, or that's something maybe the next step?
So we have actually considered that. So because if we directly take because the parameters are there, and the parameters values should be based on the user who is in front of us on the input. So suppose for the type of investment, should I considering it as an example? Suppose the user I want to invest in the commercial property only. So we will be weighing the parameter appropriately according to the user inputs needs. Suppose there's a age factor. So age factor won't be directly as a parameter input to a model, but it's decision. Like what inference can we draw from the age? Suppose he wants he will obviously want a short-term investment depending upon his age. He wants a return faster because some of the factors that are involved with the age. So then we will be decreasing the time period of the investment. So basing on the inputs that the user gives, we will be deciding on the certain factors that we can change in a model.
Okay, thank you.
Yes.
Yeah. So no more question from my side, Vishal.
Yeah, same here. Thanks, guys.
Okay, thank you very much, sir. It was a nice talking. And so sorry for the mishap in the between of the net connection. Thank you very much.
No, we all agree there should be a decision tree.
Yes, exactly, sir. Thank you very much.
Thank you.
Thank you, guys. We will start with the next team. Team 41, are you ready with your presentation?
Yeah, we are ready. Am I audible clearly?
Yeah, you're audible clearly.
Yeah.
You can start the screen sharing.
Yeah, just give me a second, please. Can you please confirm if my screen is visible?
It's visible.
Yeah, just a second, please. Yeah. So, should I start?
You can start.
Okay. So, hi everyone, I'm Rishikesh. We are team 41, and I have Sai with me, who is my teammate. So the use case that we worked on in this competition was about online dispute resolution, which essentially is about automating the complex decision making for disputes which are typically present in India with respect to the Supreme Court and High Court. Giving you a context about what do we have what do we have worked on. So the platform that we are planning to build recommends a resolution to legal disputes between different parties based on the parameters of the case and the previous history and the precedent of the similar cases. The beneficiaries of this model are the parties involved in the dispute by helping them save time and money on legal fees and come to quick resolution. The country's legal system will also be an actual beneficiary by helping reduce the caseload on the system. So just explaining a bit about the current process. So giving an example, there are two brothers who are engaged in a land inheritance dispute and they approach different lawyers to register their case in the civil courts. After multiple rounds of hearings, a resolution is reached and is binding on the parties. This process spans multiple months and includes heavy engagement from both the parties and even the lawyers and even our case on the system. So there are multiple problems in the current process, which includes heavy litigation costs incurred by both the parties as legal fees. The process spans multiple months and years, as I mentioned earlier, and we got to know that the high courts typically take around 4 years on an average for one case, and it requires high engagement from both the parties. The judiciary system experiences a heavy caseload despite a large number of cases being very similar, and that's the problem that we are trying to solve here. And through the feedback, we were asked to pick a section out of the Civil Code of Procedure, and we decided to go ahead with Section 34, which essentially talks about the compensation that can be provided to the aggrieved party uh, through various mediums, like for various cases like medical negligence or contract breach or even tort claims or land disputes. So for the sake of this presentation, we took examples of a couple of cases where we are giving some context. So first one is a medical negligence case, which is being filed against a doctor and a hospital, where there have been an instance of medical negligence during a surgery, which has a significant impact on the future life of the patient involved. The second example is a contract breach case, which is against a party B who failed to honor the contract which was set between party A and party B, and hence the party has filed a case against party B. Now we are looking at the parameters that are important for Section 34 and the relevant parameters which are specific to each of the cases that we have defined earlier. So giving an example of the parameters for Section 34, so it can be the nature of the dispute, which includes, again, medical negligence, contract breach, tort claims, land disputes. There can be evidence of loss or damage. There can be mitigating circumstances. There can be degree of fault of the accused party, the precedent which was set earlier on similar cases, the statutory provisions, the inflation, the cost of living adjustment that has impacted the aggrieved party, the lost earnings and business opportunities because of the impact that it had, the negative impact it had on the party which was suffering, the pain and suffering caused, the future expenses that had to be dealt with, the punitive damages, the insurance coverage, the ability to pay of the accused party, the contribution of other parties involved, and the statute of limitations. Now, when we look at the medical negligence case specifically, there are certain parameters which are very contextual to the case involved. So, for example, when we look at the medical negligence case, there can be a parameter which says, is there a permanent impairment or disability caused by the injury or by the surgery? The standard of care expected from hospital in such cases is a parameter that comes up for this case specifically. There can be evidence of any previous compensation received by the patient for the same injury, and the relevant laws and precedents in cases of medical negligence. So the highlighted ones are the new parameters that can be added based on medical negligence. When we talk about the contract breach case, there are the terms of the contract, the evidence of goods delivery, the evidence of non-payment by party B, the law which is applicable to the contract, and the damages suffered by party A. So all in all, when our model is being used by a lawyer, they give the input parameters based on which the model understands the type of the case. Then the model will be pre-trained with enough data based on the precedence so that each parameter is associated with a particular weight. When the lawyer inputs the parameters, they get multiplied by the weight associated. And finally, they give out the expected compensation with a certain probability. In this way, the aggrieved party, or so we call the plaintiff, will essentially know that what compensation they're going to receive and what probability, with what probability is the compensation they're going to receive. Handing over to Sai.
So let me tell you about a simple case. For example, let it be a case 1 and P1, P2, P3 be the parameters based on which a Chief Justice announced a compensation for case 1. And for each of the parameter, W1, W2, W3 are the weights associated with the parameters, which represents their probability in making the case win for the plaintiff. It is dependent upon the case. Hence, we are going to take the expert here, the lawyer experience. For example, W2 is the weight of the parameter 2 given it is case 1. So probability of P2 given case 1 is W2. Similarly, it is calculated for all the other parameters. So let me consider another case 2, which is having parameters P2, P4, and P6. Here you can see P2 is a common parameter between case 1 and case 2. So here the W2 given by the domain expert is going to be probability P2 given it is case 2, which is W2, so on and so forth for all the parameters. Now, when I consider case 1 and case 2 together, the probability of the parameter P2 is given to be probability of case 1 multiplied by probability of P2 given case 1 plus probability of case 2 into probability of P2 given case 2. And as we train on different examples in a model, this is going to become more complex, and each parameter might be interdependent dependent upon the number of cases we are going to train. So hence, the more the number of cases, there will be more number of interdependent parameters, and their weights are adjusted according to their conditional probabilities. So let me give you a sample example. Let's say a person reaches out to a lawyer for a tort case, come landlord and tenant case. Lawyer inputs the parameters which he can see into a model. Since our model is trained with a large number of parameters from the data, model outputs the probability for each of the parameter entered by the lawyer. So summation of all those probabilities for all the parameters given by the lawyer gives the total probability that the person is going to win the case. If the probability output by the model is marginal or less than particular threshold defined by the domain expert, then the lawyer can suggest to take action accordingly. Like instead of roaming around the courts for 4 to 5 years, it can go for mediation and so on and so forth. So if the compensation details are also available during training of the data, we can simply multiply these probabilities and also calculate the compensation that the person is going to get even before going to the trail. So this is a sample knowledge graph how we can expect. So there can be tort claims, contract claims, and so on and so forth. So finally, there are key issues in the online dispute resolution.
So even if we talk about the online dispute resolution, there are certain issues with respect to the online system of things. There are trust issues, there are identity and digital signature issues where the forging can happen. There are data security and confidentiality issues which can occur in case of online disputes. There are privacy concerns which both of the parties may have. And also because currently there aren't any laws which are governing the online dispute resolution. Everything that is happening in the online dispute resolution is in the shadow of the law and may have compliance issues in the coming future. So that's about it. Thank you so much. Happy to answer any questions.
Very interesting subject, to say the least. There are many AI solutions being worked on the judiciary side of it. The question is this. I mean, given the variety of sections that apply, right? Are we going to have? I'm assuming we're going to have multiple these decision models for different sections. But is there an overarching one that can be there that says the case has merit or not, and then it goes into the other set of models and says, I mean, what is your thoughts around that?
So our thought is that this is particularly for section 34, which we can calculate the compensation. Since it is more numerical, we presented it, but there can be, as you said, the example, it is more sort of theoretical. Once if we have data, we can definitely train it. So the only thing is here, the step, it goes just a more step before. That is going to be section 34, and we can have similar for section 32. And based on input parameters, it can go to different parameters completely.
So would you agree that given the civil disputes, I mean, we can't go into criminal right now, let's say, given civil disputes, all of those could essentially be encapsulated in a decision model like that?
Yeah.
Okay.
Yeah, we can encapsulate.
I'm good. Anuj?
So just adding to that, if I can. So majorly civil disputes, typically the end goal of making a civil dispute resolve is basically getting some compensation. And Section 34 outlines like the compensation that the parameters for Section 34 essentially outlines the compensation and the probability of getting that compensation. So if we talk about the rest of the sections as well, the end goal of majority of the civil claims is getting compensation from the accused party. So we can have relevant parameters and relevant data in numerical format, which would essentially give us the probability and even the probable compensation that the aggrieved party can get.
So you're saying, as a generic approach, no matter what section applies, there is money involved. There is no proper way to calculate how much that quantum of money should be, right? It's a good way for you to say whether the money will be there or not, and if it is, then what is the quantum of that? That's what you're saying.
Correct.
Now you can apply the same to any kind of a section for that matter.
Yes.
Okay. The weightages may differ though, but you're saying the general or generic principle applies.
Yeah, the weightages would be dependent on the precedent that has been set in the earlier results by the High Court and Supreme Courts.
And that's why I was saying for somebody to get started, either you're saying, and I may not be the best guy to legally determine this, but either you're saying these are the ones where it will have the most impact, these sections that you quoted, and say get started with that and expand into other areas.
Correct.
Or the other way is you say, let's build an overarching decision model that actually says ultimately the paisa involved here, so let's go with the paisa mode of it. Compensation is the one to focus on, and plug in the sections into that.
Right, because I think if we look at the model, getting the probability of compensation and the amount of compensation would also would be a positive thing for both the parties. Like they would feel that okay, this issue is getting resolved in say lesser time. Money spent on the legal fees is less, and they're also getting a rough idea about how much compensation are they willing to pay or not, based on the like just a model. Within 5 to 10 minutes, the lawyer can tell to both the parties how much they have to pay or how much they would get in case they decide to proceed with a similar issue.
So the only last question I have, see, biggest problem we face in India today is that the compensation around accidents.
Right.
That's the one that drag on 4 years in the courts. Well, there's a state calculation. Most times the public doesn't even know how much they'll get. So I'm assuming this can be extended to that kind of thing also. So you have an accident because of unfortunate circumstances. And then based on the insurance party involved and you involved, what is the compensation you may get?
Correct.
Yeah, here itself, like we are defined personal injury, we did not extend upon just to don't make this slide messy. So here in the personal injury, we can extend to the parameters, extent of how much extent of the injury he got, what are the expenses incurred in the hospital, what is the statutory limits, which is essentially the insurance, so on and so forth.
Got it. Thank you. I'm done.
Yeah. So essentially, what we mean to say is, in the case of an accident, unfortunate accident, we would be able to get a rough number on like types of vehicles or types of injuries, or say it is if it is a permanent disability, then the typical compensation which has been received in the past. If there's a case of unfortunate death of a person, then the relevant compensation that can be given to the family. And even if there is a loss of just loss to the vehicle itself, we can have specific compensation that can be assigned to, and specific parameters which can be assigned to the degree of destruction cost to the vehicle.
Thank you, team. I think we'll move on with the next team now.
Understood. Thank you so much for your time.
Problem. Nitin, can you test the buzzer sound now?
Just a minute, Ananya.
Yeah, sure.
Is it audible?
Audible. Cool.
Okay.
So we'll start with team 59 now. You can begin your screen sharing. Team 59, are you starting? You left the meeting. Okay, so in case team 59 is not starting, is team 57 ready?
Yes, we are ready.
Okay, so you guys can start as soon as you can start your screen share.
So shall we start now or should
Yeah,
we
yeah,
wait?
you can start. There'll be two buzzers, one at the 3-minute mark and one at the 3.5-minute mark and one at the 6-minute mark for you.
Okay.
Hello.
So
This from team 59. Actually, we had a small technicality issue. Can we?
Okay, you can do it after this presentation since I've already started the screen sharing.
Oh yeah, sure.
Okay. You guys can begin team 57.
Alright. So I think can you see the screen? Hello, anyone?
Yeah, screen is visible. You can go ahead.
Okay. So good afternoon, everyone. We are team 57 and we are going to present our model for the looked up event, Cognitive Garage. Our model's name is Ready for the Event. So have you ever been in a situation in which you didn't know what to wear for an event or occasion? Yes, right? We have been too. It's exactly the problem which we have with our model. In everyone's life, one has to attend many events, right? It may be personal or professional, and the person would like to present themselves the best there. But one common problem is to decide what fits them the best. Almost everyone faces this issue. This model helps people to decide what fits them the best in a particular occasion. So now let's talk about the table of contents. So our main idea is to recommend appropriate outfit for an event by taking into consideration the various parameters and inputs person's input. How we do this? We're going to automate this, and at last, the target of our model is to recommend an appropriate dress based on the person's requirement. Now let's discuss something regarding the fashion. Fashion is a timeless art form that embodies the essence of individualism and cultural diversity. It is a reflection of the world in which we live, constantly evolving to embrace new ideas and trends. Now, my friend will continue with the work model.
Okay, so our workflow of the model goes like this. The user has trouble deciding what to wear. Obviously, that's where we come in. We take in some information from the user, like occasion, preferences, etc. Now, this information will act as parameters for decision making. This decision making will produce some outputs, that is from outfits, and the user has to select one of these outfits. Now, now I'll be talking about the parameters that we take. A model considers these parameters at one's dressing sense. A few of those parameters are gender, age, occasion, weather, personal preferences, and personal details. Few of the personal details are skin color, body shape, hairstyle, hair color, eye color, face shape, and many more. We also take into consideration the weather that day and the time of the occasion. And according to that, we will suggest an outfit which will take the weather and event into consideration. We might also try to suggest some add-ons like a long coat or a watch, which might help to enhance the look and outfit without changing the outfit. Now, I'll to explain this to you with the help of an example.
So let's assume a woman as a user to use a model to get recommendations for the dress to wear. Firstly, the model asks the person to select the gender and then the age. We divided the age parameter into different age groups, which are like 0 to 5, 6 to 12, 13 to 25, 25 to 40, etc. And so on. It goes about till 66 and above. For each age group, we kept different occasions that we felt were accurate and relevant to that age group. This is like the dependency model. And further, we classified them into smaller events. Then we provide each sub-event with some appropriate outfits. For example, if we take the occasion as formal event, this is further divided into sub-events like weddings and receptions, award functions, annual days, etc. Now, if you take the sub-event as a wedding and reception, then it asks about the weather conditions for checking any dependencies to filter out some vague recommendations. It also asks to what is the preferred color for choosing the outfit that she wants to wear. And it also asks for personal details like face shape and eye color, which eye colors like red, blue, which different people want to put on. Body shape, height, and hair color. Hair color also consists of various types, and it also asks for the skin tone. Now it also now we come to the fact that we have to take the type of outfit, choose the outfit that she wants to wear. Based on collective personal information and preferences, it suggests an appropriate outfit. It also asks about the type of add-ons that she wants to wear, like earrings, necklaces, bracelet rings, footwear, and recommends accordingly. Now, my friend Sudhakar will continue with the interdependencies part of the parameters.
Okay. So we take in a lot of parameters from the user, right? Now these parameters are interdependent in some or the other way. So choosing an outfit involves several parameters that affect each other's and overall feel of the outfit. Let's look at some of the evaluation. The first two parameters which are interdependent are weather and color. Outfit is influenced by weather and personal preferences, as certain hues are better suited to different temperatures. The relation between the two can be summed up as a blend of practicality and personal preferences. For example, on a sunny day, you may choose to wear something light, like white or pastel. While on a crisp fall day, you may prefer to wear some richer color like burgundy. Now, body shape and outfit are also interrelated. Outfit selection can be influenced by body shape, with attire chosen to complement one's natural curves and proportions. For example, a pear-shaped figure might opt for A-line skirts to balance their proportions, while an hourglass figure may prefer outfits that hug their curves and highlight their natural silhouette. Now, next, skin tone and outfit color. These are also related. Certain hues complement or contrast with one's natural skin tone. A warm skin tone might look good with earthy shades like olive and rust, while a cool skin tone may benefit from crisp colors like navy or white. The goal is to choose colors that complement or contrast in a pleasing way with the skin tone. Next is occasion. Young people generally go to informal events, right? Like parties and all. So we recommend casual wear, while older people generally go to formal events. So they are recommended to wear formal attire. These are some of the interdependencies which we have come across. Now, experts are Dr. Vaneet Kashyap and Shivani Nathani, whom we consulted to get this information. I would like to conclude by telling a quote. Fashion is a movie. Every morning when you get dressed, you direct yourself. By Thierry Mugler. Thank you.
Any questions, my panelists?
Vishal, you can.
I would say, pretty wide set of parameters that I never thought of, guys. I was like, wear a jean and shirt and you're done. But this is so amazing. I'm sure you have an audience for it. Really believe so.
Sorry, sir.
I think
Your voice is a
automation
little bit
is
low.
the only part. Sorry, you were saying?
So your voice is a little bit low. Like, can you please be a little bit louder?
Okay, let me repeat that. I was saying very relevant to how things are evolving now. It's not your audience is not just the fashion industry; it's an individual who has to go out on a specific day, right?
Yes, it's more personalized.
Just enlighten me on the automation part of it, and I think this is interesting.
Yes, sir, we should do this. So, in terms of automation, what you try to find is some abstract parameters at the start, which also classify them with the main parameters, sub-parameters, and so on. These abstract parameters are like fixed, like which don't change day by day or so, something like that.
I meant, let me ask you this then. Let me ask you a pointed question. Sorry, I'm stopping you because pretty less time and there may be other teams.
Sure.
What I mean to say is, do you envisage this being used in a bot kind of a fashion wherein you're asking questions, somebody gives you answer and you suggest something, or you go in front of a glass which has a camera, it figures out all these parameters and then says, well, this is what you should do. The whole idea is,
for now, what we are thinking is that it's like this only. You will give us some information and things like that. But then we can also improve this model by taking like keeping a camera in front, which will take your skin color and then your hairstyle and everything, the body shape, and then it will give you a recommended dress. That can be done, sir, but that is of a little bit higher level. So we decided to go with something that asks you the questions. Like some people might not be comfortable, right, giving their
So one more thing to add, that we also thought of including augmented reality into this, so that it creates a 3D space, and we can easily put our our avatar and ask us to particularly put this dress or put this add-on, and gets to choose from that.
Yeah. No, but that's when you have made a decision for a dress.
Yes, sir. And
you're
that's what,
showing
that's the
how it looks
last
on you. Yeah. Yeah. But it's like, so the dichotomy here is, and the dichotomy being, it can be very wide with the choices you can make based on what all you can be asked. But the other part is, people want to say, don't ask me hazar things, just tell me, which means some of this data may need to be inferred rather than being asked from the individual. That's all I have. I mean, this is amazing the way you have thought through this. But as I'm saying, the automation part would need to be very simplistic, so that you're not boring somebody to death by asking varied set of questions, right?
So we thought through this. Just to mention, we thought through this. We asked to what we kept in our mind is to ask user only very abstract questions. Not any particular type of questions. The automation part takes care of the very detailed analysis. So as of the user perspective, we'll just ask very basic questions, not to confuse them, or not to again search on internet what does this model mean. So that's what we want to say from our part.
So to just add on, I could also say that this is just the base model, sir. We could also try to as you said, we can use some camera and image processing to directly infer everything and just take occasion as a parameter. That can also be done, but this is just the base model, the base thing that we thought.
I get it. Thank you.
No, I think that's good. And actually, as you rightly said, a lot of these parameters are actually one-time parameters, and then few are occasion is what you ask, and few are dynamic, what is the current fashion trend, or whether you are going for a outdoor party or indoor, and all those things. Anyway, this is good. Thanks. No more questions here.
So thank you for your questions, and I hope you got your answers. Okay, sir.
Okay, sir. I'll stop sharing the screen.
Thank you, guys. So we'll start with the next team. So team 59, are you ready now?
Yeah, we'll just share our presentation. Just a second.
Sure.
Yeah, I hope we are audible.
You're audible, and yeah, your screen is also visible.
Yeah. So today we, the members of Team 59, are going to present the lifespan prediction model before you guys. Now, primarily, what are the shortcomings of the pre-existing models? The pre-existing models only focus on a singular or very limited number of parameters, like the region a person belongs to, the country they belong to, or maybe their gender. Now the problem is, now let's for example, a person is facing cancer, and so the country he lives in is not the primary parameter to judge his lifespan. So what is the solution? One way to improve this is by increasing the number of features in the input data. Now to achieve this, we'll have to incorporate various parameters, like obviously the traditional ones like gender, race, and the region they belong to, their ethnicity. Apart from that, we have to focus on their diet as well, the AQI of the region they live in, their income, because obviously poor people do die from starvation. There are a lot of wealthy people who die from, let's say, obesity as well. But we have to incorporate all these parameters as well. Now, we live in a time when we talk a lot about mental health. So parameters like social isolation or your sleep deprivedness can also lead to, can have an impact on your lifespan. Now, apart from that, we can talk about educational levels, stress levels. So all of these parameters need to be incorporated as well. Now, why do we need to do this? What are the use cases of such a model? Such a model can be used for insurance policies. Now, insurance companies do ask a lot of questions to their users, but still don't have a very precise idea of what their expected lifespan can be. Our model can help them to have a better and more dynamic look at it. Apart from that, government has to make a lot of policies on basis of the lifespan of average population, and if we can find out the parameters which have more weight in our model, government can focus on those specific domains to improve the overall lifestyle of the population. Now, Weber will dive in technicalities of this model.
Yeah, so hello everyone, this is Weber Arora, and now let's dive into the technical things. Now let's start with the introduction of Bayesian models in general. Now Bayesian models, they are simple probabilistic graphical models used for probabilistic inferences. And the usual type of the network that we have is generally a directed acyclic graph, wherein the nodes are the parameters and the edges are supposed to be the dependencies between them. So typical example of such networks would be as it is in front of you. Here we have.
Sorry, you can skip this, right? We all understand.
Yeah, okay, great. So now we'll go with our solution that we propose. So, well, the methodology that we followed here was that we collected multiple parameters, understood how they affected human expectancy through various blogs, research papers, domain experts that were available in our own institute. And then, well, since placing the parameters in a directed acyclic graph manually can be very challenging since it's an exhaustive search, having more simplicity into our model, which was by incorporating a MECE framework. Now, MECE stands for mutually exclusive, collectively exhaustive, meaning that like we speed up our graph modeling by avoiding split based on data induced parameter dependencies, which means that basically we prune the dependencies in our model. So I'll just give you a brief visualization of our model. So we have an input multiplexer, which like takes some basic input from the user. We have many states, a Markovian chain sort of model, which are stacked together in, to be specific, there are 31 such states, and then there's the output multiplexer, since our output is supposed to be, high, low, such categorical output. So now, understanding of the model, we come to that. Now this MECE framework helps us to build a chain which makes the model simple yet inclusive of all parameters. As I said before, it's pruning the dependencies, and the input multiplexer is nothing but a hash map. And well, it's supposed to bring generalization into the model. And as we go into the states further, we get to more personalized parameters. And in layman terms, each state represents a question, and based on the answer, a weight is returned. Weights are nothing but they're supposed to represent gains or values, loss value in the base value. So yeah, our model is pretty simple. For each state, we have an input AI and the output AI plus 1. There's a weight attached to it, and as we move forward, this weight gets multiplied simply. It's nothing but a form of regression, so to say. And since these weights are modeled around one, the more the deviated they are from one, the more impactful they'll be, because obviously that's how much they'll contribute to the weight, to the gain or loss. So yeah, our submission here was a bit complicated to fit in one slide, so I'll just zoom in. So yeah, we have included parameters such as gender, race, diet, AQI, income, step, sleep, spirituality, smoking, etc. And all of these are questions. So and finally, we traverse this graph based on based on these weights, and we get to a final age range, which characterizes our data. So yeah, that's pretty much it. Thanks for your time, guys. We are open to questions.
Yeah, thanks.
Yeah.
So sir, maybe you want to understand this graph. How is it's different than Bayesian, right?
I'm sorry, sir.
No, I'm just asking Vishal to maybe ask questions.
Yeah, I mean, it's an interesting way you have laid it out.
Yes, sir.
That is the Bayesian approach, you have this kind of an approach. That's what I'm just trying to understand.
Yeah, the thing here is that the weights that we're defining here, they are based on certain statistical data which we have mentioned in our references, and that's how it is correlated to Bayesian models actually. It's essentially like a state machine, but the weights that are being reflected here, they are based on certain assumptions.
So Vishal,
Yeah.
I mean, the way I see is, I mean, if there is not too much of correlation or interdependency between these variables, then possibly you don't need a Bayesian network. I mean, then it's more like, this kind of a graph where essentially you are determining the weight or score of each parameter, right? I mean, that's what
Yeah. Yeah, right. And the reason we did that is because, because some types of data are hard to procure. So we went with the more generalized approach. And another problem that we found was that based on the region, it was hard to find the suitable data, so to say. So yeah.
Interesting. I get it now. Yeah. Thank you.
So any other questions, guys?
No, I think we are clear. Thanks.
Yeah. Thanks, everyone.
Thank you for your time.
Thank you.
Thank you, team. Next we have team 49. So can you start your screen sharing, please?
Yes, just give me a second. Ananya, can you just give me a quick audio and video check?
Yeah, audio is visible, video is visible, screen is also visible.
Okay.
You'll be given two buzzers, one at the 3.5-minute mark, one at the 6-minute mark. You may begin your presentation.
Sure, thank you. So hi everyone, Aditya here from Team 49. So for our Bayesian network, we particularly focused on one particular segment, that is the EV batteries, and one particular very small subprocess, that is the second life application of these EV batteries. So what our Bayesian model is trying to optimize is the lithium-ion EV batteries we use through process mining. So just to give you a quick glimpse about what process mining is. So in very layman terms, it's just using the data from the existing processes and the industry to understand what are the current bottlenecks in the process and the overall cycle, and to come up with some improved solution to increase the overall efficiency. So moving on to why this particular problem and what are the current very specific bottlenecks into this particular domain. So one very important parameter to understand when considering the second life application of these EV batteries is all the batteries present in the electronic vehicles. Once the capacity drops below 80%, these are considered no longer suitable for the electrical vehicles. So that is even after even though after the 80% capacity has hit, even though they are not sustainable in the EV segment, they still have a very large application as a second life application into various segments. One of that can be the grid energy storage system. So one of very basic starts to highlight this is even after 80% capacity, a single typical battery that was designed for 1500 cycle still has enough power in itself to sustain a home use for roughly over 15 years. Going on, some of the key bottlenecks that the model is trying to tackle in the current segment is, and this is because even today, despite availability of resources, only 20% of these batteries actually enter a second life application, and this is majorly due to some of these reasons. The first being the logistical and the capital expenditure required from both the OEM, the original equipment manufacturer side, and the second life application user side in terms of acquiring the battery right from its source to managing its entire logistic and during the refurbishment process to its end goal, that is in hands of a second life user. And this is mainly due to the uncertainty of determining its exact and optimal use case of that particular battery. So even though the initial batteries may have the same specification, after the use, depending upon the use, these may have some very different capacities, very different parameters left in them, and according to which an optimal use case for this needs to be defined. And currently there is no streamlined process in determining this or actually assigning a book value to these batteries in order to compete them with the first generation batteries for those particular use. And thirdly, one of the key challenges again is the lack of resources in terms of actually going beyond these second life applications, beyond just the energy storage system for large applications, that is the grid and the renewable sources. So through this model, we are also trying to diversify the options available with the OEMs and the third party systems in a way to refurbish these batteries better and to expand the market scope in terms of the second life application.
Good afternoon. I'm Abhishek, and I'll just explain our Bayesian network. Yeah. So as you can see, this is a Bayesian network, the directed acyclic graph for the Bayesian network, and we have considered over 80 parameters. Majority of them analyzing the initial battery conditions. So we have two types of decisions here. One is a purely technically driven decision, which takes into consideration the battery conditions of the used battery, the complexity of the process of turning it into the final use case, and also the most important is the sustainability factor. Is the process sustainable? Are we reducing the overall carbon footprint? But of course, our organization cannot only look at the technical, it also has to look at the financial aspects. So in terms of the financial decision aspects, we have the operating expenditure of the process of refurbishment, the cost of the manufacturing process itself. We also give it a complexity score, like is the process too complex? Will it require a lot of technical intervention? And we consider the financial aid that we get from the governments and the other organizations, since uh, this is a process aimed at sustainability. And all of this is compared with the cost of the new products in the market. So if the cost of the refurbished product is higher or greater than the cost of the new product, then it's not really a sustainable business model. So you could just go to the next slide. Yes, so these are the possible decisions that our model will help us to segregate our used batteries into. So each of the following use case will have a different technical requirement, and our model will help us to segregate a used battery into one of these use cases. So we have a use in the grid services, providing support for electrical grid. We can use the refurbished battery as a backup power system, as a frequency control system. You can use it to in the charging infrastructure for new electric vehicles as well. We just yeah. So then we could also use it in portable devices and power tools, where there are again different technical requirements exist, and in lighting systems and second life battery storage also. So for an example, let's look at the case of backup power. A backup power, if you're using a battery as a backup power, it needs to have a long discharge time, and it needs to have high capacity to provide power for a long duration during power outages. And in terms of grid service, in terms of charging infrastructures, faster charging should be able to handle many discharge cycles without losing the capacity very quickly. Moving on to the economic benefits.
I guess that will be like majorly like some of the potential decisions. I guess like we're open to questions and like more discuss on the Bayesian part of the model.
Yeah, thanks. I think the use case is definitely very interesting, and we are also clear on the approach. So first question is on the automation side. I mean, because you're dependent upon the parameters about the battery, right? I mean, so do we have any sensor which actually can give us all the parameters required, for understanding the health of the battery, or it needs to be manually, entered? How, the question is how will we get data about the battery?
Got it. So Parth, maybe you can take it.
Hi, am I audible?
Yeah.
Yeah, hi, sir. So there's essentially a battery management system which exists inside an electric vehicle, so which takes charge and control of all the aspects in regard to the car and the battery. So it has, as you have mentioned in the parameters list, you could see that there is from battery end of life to temperature sensors to everything. So the battery management system is essentially a complete ecosystem where it can give you everything from possible parameters to even decisions itself. But the decisions are only limited to the car. We only need the data.
Got it. And that data is easily portable, right? I mean, so basically, we can get that as an input to our network, right?
Yeah, it's essentially software.
Yeah. Okay.
So like just to add on to his point, so like majority of the very hyper technical parameters that like exist in the model can be directly imported from the battery management system, and the actual additional expertise that may be required from a subject matter expert will come into place while actually like determining particularly depending upon the battery, like determining like how, let's say, for a particular input value of capacity and all, how actually like that can be used for different applications, and majorly the finances and the sustainability factor depending upon the OEM's requirements.
And who would be the user of this model? Will it be battery companies, the EV manufacturers, or the end user?
Sure, sir. So I'll take this. So basically, like there are multiple stakeholders involved in this. The first and foremost will obviously be the OEMs, that original equipment manufacturers. This will include both the pure battery manufacturers as well as the EV manufacturers, and this in particularly will like help them significantly. And this is already in place. So battery reuse, like as I stated, is something. The second application is already in place. There are multiple automotive industries that are practicing. The most prominent maybe the Tesla, but still the final applications for this battery within this organization remains to the in-house applications as a secondary storage systems, and they have not actually expanded beyond this. So this in itself for EVs as well as the OEMs also presents as an opportunity to expand beyond their in-house applications. And we can also see use case from a third-party system who can act as an intermediary between like a resource person who collects the second life application batteries and is able to refurbish them into the further use. If someone would like to add more on this.
Okay, got it. Okay, thanks. So no more question, Vishal. And any question from your side?
Nope, I'm good. The only thing I would say only an Indian mind can think of, actually thinking beyond the normal use that people think. A genuine approach. Very good approach.
Thank you, sir. Again, thank you all for your time. Thanks a lot.
Thank you, team. We'll be moving on to the next team. Team 43, are you ready with your presentation?
Yes, we are ready for a presentation.
Yeah, okay. So you can start your screen sharing. There'll be two buzzers, one at the 3.5-minute mark and one at the 6-minute mark.
Please can you wait for a moment? Yeah. Okay. When will we get the queue to start?
You can take your own cue and start. We'll start the timer then.
Okay. Okay, then we are going to start.
Can you confirm if the screen is visible?
Yeah, it is visible.
Okay, then we're going to start. Good afternoon, everyone. We are Team 43 presenting for Cognitive Garages, easy automation of complex. 1 minute, please. We would need to stop and restart again. Okay, so good afternoon, everyone. We are Team 43 presenting for Cognitive Garages, easy automation of complex decision making. The problem statement required us to find and dive deep into a use case requiring complex decision making to provide benefits of scale, improve accuracy, shorten the time, or make better quality decisions using facts and data, and come up with the parameters that impact the decision with the help of the domain experts' input. The use case proposed by us is automated risk assessment for infrastructure auditing. Through our solution, we seek to decrease the subjectivity involved while determining the vulnerability of a fault in the building using Bayesian belief networks. Our model will contain several parameters with the integrated inputs from the building's historical data, its characteristics, outside influences, and the outcomes of the visual inspection undertaken. Based on how they are interrelated, the program will then take these inputs and produce a risk score for the building. It will then give a probable list of the non-destructive tests that should be conducted to pinpoint the problem if and when required. This would speed up decisions regarding the numerous repairs and retrofittings needed while also making the auditing process more efficient, convenient, and cost-effective. Numerous pain points plague the construction and auditing market. As a biggest concern, the Indian landscape is prone to natural disasters requiring frequent audits and inspections to prevent their collapse. Meanwhile, the auditing industry is also facing a decrease in a well-trained and experienced workforce, which may reduce incorrect bias in the inspection. This sector also suffers with respect to affordability, as many non-destructive tests are expensive to conduct but are listed by the auditor unethically.
A major problem associated with automating the structural auditing process is the lack of well-documented historical audit data. This renders models like ANNs and fault trees useless. That's where Bayesian networks become the perfect fit, as they fill the holes in historic data with inputs from the domain expert. Another advantage of Bayesian network is its ease with which it can be implemented, making it more valuable to the structural auditing industry. So let's straight away proceed to our proposed Bayesian model. This is the complete structure of our model. The fact that it is so complex again reinforces its need in the auditing domain. So we divided the entire structural auditing process into 4 buckets. The first is the historical data of the building, like its age, floor plans, previous audit scores, etc. Next, the on-site visit is divided into environmental factors, serviceability aspects, and structural information of the building. The structural auditor inputs the data into our model by simply using the chatbot. The model then generates 14 different risk scores between 0 and 1. If any risk score exceeds the threshold level, non-destructive tests or entities shall be suggested for further investigation. Additionally, the model outputs a cumulative risk score of the entire building to try and identify the urgency for the repairs and retrofits. Moving on to how exactly the model works, the model buckets are further divided into parameters based on the possible visual observations. For example, the serviceability bucket is further divided into cracks, dampness, deflection, settlement, and vibration. The chatbot asks for input for these parameters. For example, if the auditor sees some cracks, he mentions its floor, the crack measurements, location of the crack, and so on. It is based on these information that the bucket risk scores like corrosion extent score, dampness score, and so on are calculated. Now, talking about the mathematical part of the model, we calculated the bucket risk score by multiplying the input parameter score with the probability with which it affects the risk bucket. Similarly, the final risk scores are calculated by multiplying the individual bucket risk score with the probability with which it affects the overall risk profile of the building. The various conclusions from the risk score are shown on the slide. To calculate these exact values and interdependencies between parameters, we took inputs from civil engineering professors and PhDs and further verified their applicability by contacting the on-field structural auditors. To give a better idea of how this model functions, let's consider a case of a 10-story office building situated in an urban area. The structural auditor inputs the values of the parameters and the bucket risk scores are calculated as shown. The red buckets signify the buckets to be at high risk and therefore corresponding entities shall also be suggested. The final risk score of the building comes out to be 6.2, basically implying that the building needs some moderate construction reforms with specific damage reports like weakening of foundation strength, leakages on 6th and 7th floor also provided.
Now, coming to the business study, we bring in the technical, economic, legal, and organizational feasibility with the probability distribution provided by the domain experts, the gap created by the exit of an experienced workforce, and the Indian mandates. The scalability of our knowledge model can be assured by the decreasing costs of the IoT sensors installed in the buildings and increasing investment in the infrastructure market by the private sector with an additional investment of $1.5 trillion by the Indian government. The future scope in this domain can catch the faults in due time before it can even cause much damage. Our knowledge model is targeted towards a risk assessment of commercial, residential, and industrial infrastructure. Apart from the residential buildings, we can expand it to infras like overbridges, stations, mines, power plants, and many such structures by integration of appropriate inputs by respective user experts. In the end, our use case aims to make the process of inspection and maintenance more affordable in order to decrease casualties when a tragedy strikes. Our model strives to prevent the loss of lives through immediate and objective analysis and takes timely measures to inform an
Okay, thank you. I think very good presentation. You have covered all the details. Vishal, any question you have?
Yeah, I think in a way it was addressed in the presentation that the manual inspection of physical would not be the barrier. There'll be visual processing and others employed to really feed in the data design model. The only thing I would say is that there is like a pressing need for it now, and the industry that actually wants to go for that is the insurance industry, who essentially want to just employ this ongoing basis where their policies are just getting renewed and they have no clue unless until they send somebody on site. So this does have relevance. Automation, obviously, you're trying to address. Is there data available? So let me just ask this. Is this like a need, a regulated need today in any of the industries? I know for insurance it is needed. So regulated need means it is by process needed that you produce this kind of a report. For buildings, it is needed, let's say, for example, when you construct the property, what after that? So is there a regulated need somewhere where this fits in? That's the only question I have.
Yes, sir. So we looked at the model bylaws that are followed in the country as of now. It mandates that every building needs to be inspected every 5 years if its age is between 15 to 30 years. And if the building is aged more than 30 years, then it needs to be inspected every 3 years. Not only that, with time we saw that in other countries the model is being used. Such inspection reports are created very frequently, and with time that can be incorporated as the infrastructure industry grows in India.
Adding on to the point, sir, I would also like to say that in places where there are periodic natural disasters like periodic earthquakes or cyclones, the building inspections are required periodically to check the preparedness for these attacks and for these environmental conditions. Therefore, it is important to fasten the process of visual inspections.
Also, sir, adding on to what my teammate said, it would make the entire process more transparent because many a times we have seen corrupt practices in the inspection market. So when we bring automation into that, we kind of make the entire process more transparent. And right now, as we are seeing the earthquake that has hit Syria and Turkey, the major death toll was because of the collapse of buildings and because they were not properly maintained. So maybe so there's a high chance that corruption was involved in that area. And if we do bring automation, we would remove that aspect as well. So it would really be, more be saving lives when seeing in a long-sighted perspective.
Yeah, I get it. The only thing I would say when you are hit with a 7.8 earthquake, nothing helps. What does help though, is having a map. So one of the use cases probably is like, can NDRF use that kind of a solution to map each of the major urban centers where population is a few million, and say, if a disaster strikes, then these are the areas which will need more focus because of how the building assessments have been done in that area. Something like that sort, right?
Yes, sir. So we also thought that, once the natural disaster has struck a place, we can also use the model to automate the process and fasten the process of relocation so that people can be easily evacuated and relocated to places which are safe.
Got it. Thank you.
Yeah, again, Vishal, I mean, like, so the inputs from this actually can be used for, planning for the disaster and all those things, right? There's good presentation, I think, and I like, a lot of inputs, the way you have presented. Thanks. Yeah.
Thank you, sir. The pleasure was all ours.
Thank you, guys. We'll move on to the next presentation now. Team 19, are you ready?
Yes, we are ready.
Okay, so you can start your screen sharing.
Yeah, just give me a second. Okay, I hope you can see my screen.
Yeah, your screen is visible. So
Yes.
you'll be given two buzzers, one at the 3.5 minute mark and one at the 6 minute mark. You can begin your presentation.
Okay. So a very good afternoon, everybody. This is Team 19 presenting their use case on Cognitive Garage's AI automation product. And we have selected our use case as online insurance aggregator. So first of all, let me acknowledge the Cognitive Garage. They are a no-code data to decision platform, which is really a good platform so that the complex decision can be made in like using data and all sort of things to generate a decision model. So first of all, let me tell you the problem statement we are proposing. So we are proposing the problem statement as mis-selling of insurance policies and optimization of persistency ratio of the insurance company. So our customers here are insurance companies, vision and mission. So vision is that we need to provide an app policies for the customers of the insurance company so that the insurance company's renewal rate increases. So the mission is that we give access to the Cognitive Garage's AI and automation product so that the insurance company can give their parameters as well as the customers, and customers parameters are added so that a best fit match of policy is served to the customers. So what exactly is the problem we are stating? So the problem we are stating is that customers are not satisfied with the services they are getting. They are not getting the expected services. The penetration rate is very less because of the bad service and bad experience and lack of trust, confused, unclear, lost, baffled customers. So the consequences of this problem is that the insurance company's persistency ratio is decreasing, and no new customers are opting for a policy in a company, and there is a lot of mis-selling of the policies. So I would like to let the domain expert give his advice on this. So we have the domain expert. I'm sorry for the video.
Actually, the audio is not, or we cannot hear the audio.
You cannot hear the audio. Okay, so I have shared this in the Google Drive link that I have shared with you. I'll continue with the PPTs itself only then. So the solution we are providing is that we are identifying the parameters. So parameters basically what we have mentioned in the report. So there are 100 plus parameters that we have mentioned in the report as from the side of the customer as well as from the side of the insurance company. So these parameters will be taken into the knowledge studio, made out of making the knowledge model and the inference graph. From the inference graph, we'll determine the conditional probabilities, which will be based on the policy, which will give the policies that will be based on the input of the customer. And using the probabilities, we will work on the knowledge model to score for the policies which will best suit the customer's requirement. So this is our target, which is to fulfill the gap between the customer and the customer's expected service and the perceived services. Basically, the AI and the automation will fill the gap between this 1 to 3 gaps, as we can see on the screen, and easily give the customer the expected services. So this is the process. If you can see the process here over the PPT, it will explain everything over how we can go through the automation. So let's assume a case study. Let's assume there is a guy named John, and he's 35-year-old with a freelance graphic designer profile, and he has 2 children with a wife, and he lives in the suburbs. So he needs a policy which will protect his family's financial future, as well as the unexpected events such as a medical emergency or any death. So if an insurance company has to provide him with the policies, they will provide him for 4 policies. That is term life insurance, health insurance, disability insurance, and homeowners insurance. Based on these 4, how the person these 4 in these 4 also there are special offers, or there are some premiums that are given by the insurance company which the customer does not know due to the lack of information. So our knowledge model will give the person will take the requirements of the person and provide the best at term life insurance, health insurance, and whatever policies he need for his this for his insurance. So the user model will take the input and he will then do the policy filtering, and with the policy filtering he'll recommend the product with the maximum utility. This is the inference graph we have come up with our 100 plus parameters. So we'll see the person's age, education, lifestyle, medical history, and all of these inculcated with the insurance company's premium and the trust the insurance company has, the competition, the technology, the time taken for the settlement, the zip code, the area location, especially the location. Assume the person lives near the hospital, so it would be very good for the person to get the offers based on the hospital's policies. So let's talk about number, how this knowledge model will help us. Currently, the current persistency ratio is 60 to 70%. You can see it here in the graph. So the ratio is 60 to 70%, and the penetration ratio is in single digit, that is 3 to 4%. If we are able to increase 5% persistency ratio by 5%, we can make insurance company's revenue at the end of the year maybe multifold of what it is generating in the previous year. Similarly, if we are able to increase the penetration ratio to at least a double digit, then the market size of the insurance company will increase as more and more customers will come. So basically, our AI and automation product will help us generate trusted customers who will come back to the company and who will take insurance. So it is very easy for the trusted companies to mislead customers, and life insurance companies are trusted. This is how I'll conclude. This is our bibliography. You can take the data sets. We have mentioned the data sets and the references. Thank you so much, and I hope you like our use case. Any questions?
Thank you. I think use case definitely is very interesting. Just one question. You said that we basically the target for this model would be the insurance companies.
Yes.
I thought it will be insurance aggregator like Policy Bazaar, right? I mean,
it is, yes, exactly. It is like Policy Bazaar itself. So we are targeting insurance basically with this, what we are doing is we are asking the insurance company to give us their parameters, give us the trust, and so that we are able to provide policies like increase their renewal rates. So exactly, it is like Policy Bazaar only.
Yeah. So basically, I mean, the use case is very simple, right? I mean, we are taking all the input from the customer, and then we have all these various insurance products from all the different companies with all the details available to us, and we are doing the right matching, right? I mean, we are recommending the right, and it is not just a filter-based search. It is actually a Bayesian network-based, recommendation, right?
Yes.
Okay, got it. So thanks. I think I'm clear about that. Vishal, do you have any questions?
I think it got answered. I had a similar one. I mean, I can see the user benefiting as the insurance person who wants to go for the insurance. If I had a way to make the decision, but obviously the aggregator. The only question that comes though, is as a user, this is a perceptible change, by the way, you all will feel it. There is so much of information glut. So we get a lot of information.
Yes.
But when somebody is trying to ask us, we don't want to give that much information.
Yes.
So what that means is I can read up so much about an insurance through all different sources. So information is available. But if somebody wants to ask me, what do you want? I'm like, and just get me this thing based on 2-3 requirements that we want to put. So this dichotomy between information outflow and inflow to make a decision is the one where we want to use a decision model to do that. That's the motto of this whole thing, to say, well, while you have a Bayesian way of doing that, you still need to automate this.
Yes.
So that you can make the decision with wide variety of parameters, but least amount of information being gathered from you as a user.
Yes.
Now, I'm assuming in this case, if aggregator is going to use it, you have a way to process that information through their policy documents and say, well, let's populate the model with those data points. That's all I'm assuming. That's the automation part of this, right?
Yes, you are assuming right.
Okay. Okay. That answers me.
Okay, thanks. I think we are done.
Okay, thank you guys. We have now the last team here, team 55. Are you ready to present?
Yes, let me just share my screen.
Yeah, sure. You can start your screen sharing. We'll ring two buzzers for you, one at the 3.5 minute mark and one at the 6 minute mark. Your screen is visible now.
And my audio and video is fine, right?
Your
Hello?
audio is a little like it's not clear.
Hello. Yeah. Am I audible now?
Yeah, you're audible now.
Good. So yeah, I can get started then on a reverse count of 3, 2, 1, go. Have you ever made an impulsive purchase? Can you remember the last time you made an impulsive purchase just when you got a good offer? Or the last time you pushed a purchase just so that you could make the purchase when you got a good sale? Do you remember the satisfaction you felt when you got a good offer and the best value for your money? Then yes, you belong to the 45% of consumers who made 1 out of their 3 purchases in the past because of incentives. Good morning all, this is Team 55 presenting our use case for complex decision automating, which is consumer incentive design. Incentive design for consumers refers to the creation of financial or non-financial incentives that reward consumers and help them make certain decisions, purchase products, or adopt certain behaviors. Why consumer design for digital native brands? Because these brands started operations online and improved their brand experience through their online data that they were able to acquire. And for them, personalization matters more than anything, since they drive revenue through it. Let us take a look at the design market now to understand how it works. The market is estimated to be reached at a 16 billion valuation by 2026 and is growing at a CAGR of 7.6%. Some major players who already adopt incentive design are shown here, and they could be potential end users for our knowledge. What are the different types of incentive design, you may ask? These include personalized and cohort-based incentive design. Moreover, there are pull and push incentives. Pull incentives are designed to directly encourage consumers to purchase a product, whereas push incentives are designed to encourage intermediaries such as wholesalers or retailers to carry and promote a product. Now, to identify what are the complex decisions involved in the automation process, we decided to identify what unmet gaps exist in the user journey of incentive design. So few glaring gaps stood out for us. One was the lack of personalization in incentives. 2 was the improper incentive placement. And 3, the ineffective adaptability to market trends. And associated to these gaps, we identified some complex decisions that could be automated to improve the experience. These included decisions like deciding what would be the right incentive given a consumer's behavior and demographics, what would be the best incentive given a company's goals and financials, and so on. For each of the gaps that we identified more complex decisions. With that out of the way now, let me get into the description of our knowledge model. What does it do? It inputs in 60 plus parameters related to consumer demographics, profile, product details, and consumer histories, and outputs the probability scores for following decisions. 1, which incentive to provide and how much should be the incentive. 2, when in the user journey specifically, the incentive should be provided to maximize the impact. And 3, the mode of offering of the incentive to ensure it is communicated to the user effectively. Now, with these decisions in mind, we went about hypothesizing parameters that could influence these decisions. And we also got them validated by some experts in Bayesian statistics who are professors at IIM Ahmedabad. They seem to like the idea and justified the fact that Bayesian networks are indeed can be used as a good use case for incentive design automation. This is a brief look at a knowledge model. Looks complex, doesn't it? Well, let me break it down to you using the parameters as breaking down the parameters into buckets. Firstly, the consumer-centric bucket. This helps us analyze consumer behavior and buying patterns to determine what would be the best incentive for the consumer. There are several parameters listed below which help us do the same. We also have shown the impact of these parameters and the subdomains involved and what sources we can get data from for these. Here also we have bucketed these parameters into 2 more divisions based on what directly affect the output and those which do not directly affect the output. Some parameters affect intermediate decisions, which in turn directly affect the output. Next up, the product purchase bucket. Product bucket tells us that about the product availability, product demand, and inventory management, and helps us identify which products to incentivize. We did the same identified parameters and sources similarly as the consumer bucket. And finally, we had a company-centric bucket, which takes in parameters related to the company's financials and goals in mind and outputs the required incentive. So in this way, we had covered all the input parameters. Now, what does the model output? As earlier mentioned, it outputs 3 decisions. Now, we got to know that we have to identify this end-to-end solution based on an expert opinion we received from a PM at Zepto. She told that there is a dire need in the industry to provide end-to-end solutions to personalize incentives according to every consumer, rather than just a cohort-based approach. Now, to better understand how these linkages affect our final decisions, we broke down our input parameters into chains and assessed how they impacted the output. The first chain talks about how the understanding user interactions which do not directly lead to purchase can help us identify where in the user journey the incentive must be provided. Here we can see an animation of how, as the input parameters change, the probability scores of the final output also vary. Next up, in the next chain, we identified how non-payment related activities can help us identify what mode the incentive should be offered through. We have also seen some external parameters affecting this change and success metrics to observe its success. The next chain analyzes primary purchasing behavior to decide what would be the right incentive for a consumer. Similarly, the final chain analyzes company-centric and product purchase parameters to identify what the best final output incentive could be for a given user. With that out of the way, we'll also like to talk about some intricacies we included in our model. This included using pseudo variables so as to account for variables whose data we could not directly access and ensuring that parameters did not get diluted in the process. We also accounted analyzing of user interaction, which are not directly linked to the purchases, as these also have a definitive impact on the final process. Now, to actually understand how our knowledge model can be put to commercial use, we also did a case study of how it can be used for a company like Nykaa. Why Nykaa would be a good fit for us is because it is a digitally native brand and majority of its operations are still online. It has a large customer base, has a wide range of products, and has an excellent customer data management system. It offers a range of incentives which could be based on which we can curate a knowledge model for Nykaa, along with some extra tweakings and adjustments to account for certain specific parameters to help influence Nykaa's decision better. Now, if you look at 3 users here, of buying increase after utilizing of our model by providing the right personalized incentive to the right user based on their demographics and the company's goals of retention or acquisition. You can also see that the impact of automating this complex decision is profound, as it leads to increased efficiency and increased brand loyalty as well. The impact on user journey and experience is also significant, with 15% increase seen in customer lifetime value. We also identified some pitfalls such as the lack of feedback mechanism, which can be which could work around by incorporating A/B testing method, and the increased technological cost and other pitfalls, and identified suitable workarounds for this as well. Now, for the future use cases, we thought for our model, it could be further extended to incentive design for employees, incentive design for offline marketplaces, and incentive design for potential partners. And on that note, we would like to conclude our presentation and we'll be open for questions.
Okay, thanks. Just one question, right? I mean, this is one area where I guess a lot of these online companies are, trying to figure out the right model, right? I mean, and you have maybe all these even, big tech platforms doing it for ads and other things. Do you really think Bayesian network is the right, tool for this, or you actually want to do it more through deep learning?
Yes, sir. Actually,
because end of the day, for digital companies, I mean, you have a lot of data, right, which is available, right? So
got your question, sir. So the problem with deep learning approaches are, since there are a lot of parameters involved here, for deep learning, you need the model to learn from the data and understand it and then test on it. But the advantage of Bayesian networks for this is we are taking in certain 4 or 5 incentives and ranking the probability scores based on them, based on the expert opinion. And we had a discussion on this with an IIM Ahmedabad prof as well, who is an expert in Bayesian statistics, and he justified this to be a very good use case for Bayesian networks, since there are a lot of dependent and independent parameters which cannot be modeled by a normal deep learning model. Because deep learning model, you have the model run on a set of data, it gets its inferences, but there is no expert opinions input involved there which can improve the solution. So that is this expert opinion. This is why Bayesian network is a very good use case for it.
Let me ask the question in a different way. See, the way industry works on this is something called clickstream data. So every time you visit the online stores, your clickstream is being captured, right? That goes through an processing pipeline, and and that is what leads to where you are in the journey. So, and it's a very standard defined practice in the retail industry. It's called the inverted funnel. So when you come to the website, you are just a curious user. Second time you come, you are a user.
Yes.
Third time you create a sign up, you become a signed up user. And next time you purchase, you've done 5 transactions from there, you become a loyal user. So you're essentially being taken through the funnel at different. It's an inverted one. You start at the top, going to the bottom. It's only when you're a loyal user is when you start being very specific to them based on their past history and all, right? The challenge the industry faces is for the curious user to stick around.
Exactly.
Now, I'll expand the question again. This was just the Gyan part of it. The question is this a design problem or is actually a marketing problem alone?
Right. Right. So can you hear me?
We'll stick to just the curious user. You don't have too much data about them. They come to their website. You want to take them through the journey. For the loyal,
Uh,
I understand.
Yeah. So basically, here what we are trying to do is for the curious user, we'll be using industry benchmarks to understand what industry, like what is there in the industry right now, and additionally, we'll see tweaks as to what a user and a buying behavior that person has in general. And on that basis, we'll try to identify any referral mode or any other mode of incentive design that can be incorporated to them. And answering your question a little better, so in terms of design and marketing, it is both, and that is why we have identified a mode as well where the customer would be identified and notified about the incentives in addition to showing the incentive itself. So we have identified that it's a marketing and a design problem as well. That is why we are designing a structure through this, and we're also localizing a position wherein the consumer can be notified of the same. I hope that answers your question.
Oh, it does on the process side of it. My mind still revolves around: do I need a Bayesian approach to it, or I stick to my current approach and maybe improve on that? But yeah, I mean, there can be debates about it. But you guys think that Bayesian actually has more value, right? Or instant value?
Right, sir. So just to answer this question, so in terms of Bayesian value, right, as we said, we got it corroborated by an expert, but essentially in Bayesian network, we are able to use conditional probabilities to a great extent. And the fact is that through our model, we've included a lot of formulae, right, which include a lot of parameters itself. So these formulae, they directly impact a lot of parameters. So even though it might seem like less parameters, it is incorporating a lot of parameters. Therefore, given that we are able to get such a good linkage and such a good direct implication of those parameters, so that is why we think your Bayesian network is much better. And
Yeah, I mean,
and
ideally, I wouldn't have questioned on this. This is like through and through case where you need a decision. I'm just saying, let me come to the aspect of automation on this.
Right.
This is a near real-time data that you are actually having, on which you will process and transform that data and feed to the Bayesian. And then you will go and say, oh, now I should show this, right? Most of the industry actually doesn't have any, I mean, real time is never real time. It is more about, because we know a generic thing, there is a pre-built profile model that just surfaces that. I was purely thinking from that angle. I do agree that Bayesian may be a good approach also, besides the current approaches. But how is this something that actually true for an automated thing where the use case may be near real time? So that's all.
Right. And sir, as you mentioned the clicking rate, right? So we've already included the click-through rate when we were deciding where in the user journey the model should be shown. So yeah,
Right.
that was also identified and validated by one of our experts.
Got it. Thank you.
Yeah, and it identifies current triggers. Yeah. Thank you so much. Yeah.
Yeah, thanks. I think we are done.
Thank you, guys. So this was the last presentation. So we'll end the meeting now.
Thank you.